Venus, Earth's evil twin. Its clouds made of battery acid. At 900 degrees, its surface hot enough to melt lead.
Venus is pretty much like the biblical vision of hell today.
This may be the most hostile real estate in the solar system. Yet billions of years ago, Venus looked a lot like Earth. Why it changed, nobody knows. A new probe is on a mission to find out. What turned Venus from a promising Eden into an infernal wasteland? And is Earth destined to end up like Venus? November 9th, 2005. A Russian Soyuz rocket launches from Kazakhstan, carrying a tiny European spacecraft called Venus Express. Its mission, to travel the 250 million miles to Venus and find out why the planet evolved so differently from Earth. For centuries, Venus's surface remained an enigma, obscured by layers of dense clouds. Because Venus is closer to the Sun than Earth, scientists assumed it would be hot and humid. Some even imagined a tropical paradise. The perfect hothouse for life.
Venus should be about the same temperature as the Earth. And that's what we thought back in the 50s and early 60s. We thought Venus should be like Miami, Florida.
What was really going on beneath the clouds? In the 1960s and 70s, while NASA explored Mars, the Soviet Union launched a probe to Venus. Codenamed Venera, the craft beamed back the first images of the planet's surface. Not a tropical paradise, but a hostile desert. Lots of dust and no water. Venus resembles its twin Earth in many ways. Similar in size and composition, they were probably formed from the same cloud of gas over 4 billion years ago. But unlike Earth, 85% of its surface is made up of extinct volcanoes and solidified lava. The clouds are composed of deadly sulfuric acid. Atmospheric pressure is 90 times greater than on Earth, enough to crush a car. But the biggest surprise is temperature. The atmosphere is nearly all carbon dioxide. As on Earth, this gas acts like glass in a greenhouse, admitting light, but trapping heat. On Earth, increasing levels of carbon dioxide are raising temperatures a few degrees. But on Venus, the greenhouse effect has pushed temperatures through the ceiling to levels hot enough to melt lead.
We get there to find out that it's 900 degrees Fahrenheit, and it was very shocking.
The surface is so hot, rocks glow in the dark. Venus would disorient a visitor from Earth. Under permanent cloud cover, you'd lose your bearings. No stars, no sun, no shadows. To find out how these two identical twins, Venus and Earth, grew to be so different, Venus Express carries state-of-the-art instruments designed to unlock the planet's secrets. But the spacecraft's first challenge is just getting there in one piece. 5 months and 250 million miles later, the spacecraft nears Venus and the most dangerous stage. To achieve orbit will take perfect speed and timing.
Space is never really safe. There's always something that can go wrong, and you have to kind of provide for contingencies for that.
Too fast, and Venus Express will fly off into endless space. Too slow, and the planet's gravitational pull will bring it crashing to the surface.
The actual day of arrival, you have about an hour and a half that it's really kind of tricky. You want to make sure that you hit the right spot relative to Venus and that you're bending around Venus the right way.
To get into orbit, Venus Express must reduce speed by 3,000 miles an hour. April 11th, 2006. The engine fires to slow down the craft. For 10 minutes, Venus Express vanishes behind the planet. If it fails to achieve orbit, it's lost. No second chances. A 4-year mission hangs on hitting the brakes just right.
The most critical maneuver is happening out of sight and out of sound from the Earth. So it's a very harrowing time because you do lose communications for 10 minutes and everybody's on pins and needles to see what happens.
At 9:57 a.m., Venus Express transmits a signal to Earth. The spacecraft's pioneering orbit begins. A multi-million-dollar quest to unlock Venus's secrets. But first, it has to get closer. On an elliptical course around the planet's poles, the craft drops down from 40,000 miles above the surface to just 155 miles. Now, the work begins. The technology on board is a quantum leap forward from the last mission to Venus in 1990. Before, a probe couldn't analyze Venus's surface without landing. All the probes had a short life, crushed by the pressure, melted by the heat, and corroded by the acid. With this mission, scientists have found a way to study the surface without landing and keep their probes safe. Venus Express views the planet using infrared, a wavelength not visible to the human eye. Unlike visible light, the infrared can penetrate areas of cloud that are less dense, allowing the probe to peer through the clouds to the clear atmosphere below. Now, for the first time, scientists can reveal Venus in 3D from the ground up.
With Venus, when you look with a visible eye, you're limited to the very top 1% of the atmosphere. The upper regions, you see these hazes. When you get the ability to look with the infrared light, it allows you to pierce right through all these hazes and see down much lower into the atmosphere. In fact, you can go to the surface.
From 155 miles up, scientists will exploit these infrared windows to map the surface in detail never before seen. Their map will document exactly how Venus and Earth differ. Then, they hope to find out why. Despite decades of exploration, our sister planet can still surprise us. And soon, Venus Express makes a stunning discovery.
Discover the past with exclusive history documentaries and ad-free podcasts presented by world-renowned historians, all from History Hit. Watch them on your smart TV or on the go with your mobile device. Download the app now to explore everything, from the wonders of ancient Pompeii and the mystery of the princes in the tower to the life of Anne Boleyn and D-Day. Sign up via the link in the description.
A spacecraft orbits Venus on a mission to solve a mystery. Venus should be like Earth. But billions of years ago, our twin went its own way and evolved into the burning rock it is today. While studying the outer edge of the atmosphere, Venus Express discovers the first clue to what went wrong. It detects particles escaping into space, mainly helium, hydrogen, and oxygen. Hydrogen and oxygen make water. For years, scientists debated whether Venus's atmosphere held any water. Some argued if early Earth had water, so did Venus. Perhaps enough to form an ocean covering 90% of the planet. Yet Venus Express detects only a small amount of water vapor in the atmosphere. If you condensed all that vapor onto the whole planet, it would create a layer of water barely an inch deep. If Venus once had a vast ocean, what happened to it? Most scientists once thought it simply boiled away. But as Venus Express orbits the planet, scientists are forming a new theory. They believe the culprit is still the sun, but the cause is more than simple evaporation. The sun sustains life on Earth. It also blasts out a constant stream of deadly charged particles. They race out at speeds of up to 1,800,000 miles an hour. It's called the solar wind, and it can devastate unprotected planets. Surrounding Earth is a magnetic field that safeguards our atmosphere. This field is formed by movement in our iron core as the planet spins. But Venus has no magnetic field. Scientists believe it may rotate too slowly to generate one. The rotation is so slow, a day here lasts almost 2/3 of an Earth year. On Earth, one rotation takes 24 hours. On Venus, 243 days.
Well, without a magnetic field like Earth's, Venus is much more vulnerable to being affected by the solar wind and by energy in the upper atmosphere, stripping the atmosphere off into space.
Scientists now believe a combination of evaporation and solar wind strip the planet of its moisture. Venus is closer to the sun than we are, therefore hotter. Its primeval seas evaporated into the atmosphere. That water vapor might still be trapped in the clouds, if not for the solar wind.
The oceans ultimately boil off, and then when you have all that water as vapor in the atmosphere, it's very vulnerable to being broken up by ultraviolet sunlight into hydrogen and oxygen, and then the hydrogen escapes into space, and there you have it. After a few billion years, you've lost your oceans.
The solar wind smashes into the atmosphere, ripping the molecules from the clouds. Over billions of years, the water is lost in space. The oxygen and hydrogen detected in the atmosphere are the last drops of those ancient oceans. loss of water turned Venus from a warm, wet planet to a burning rock. The atmosphere changed too, from water vapor to carbon dioxide. Ancient volcanoes released trillions of tons of CO2 and set off a chain reaction, a runaway greenhouse effect, leading to global warming gone mad.
The energy for both climate and weather on planets all comes from sunlight. So now imagine that this is sunlight heading towards the surface of a planet. And on a planet like Earth, where there's not much atmosphere, as represented by these atmospheric molecules here in blue, most of the sunlight will miss the atmosphere and just make it to the surface. And occasionally you'll have sunlight scattering off an atmospheric molecule. But for the most part, you just have these yellow rays of sunlight reflecting off the surface. Now, let's set up again and look at what happens on Venus. And I'm putting much more gas in the atmosphere because now we're simulating Venus, which has 100 times as thick an atmosphere as Earth. Okay, so here's our thick Venusian atmosphere. Here we are back out in space, and let's see what happens to the sunlight in this much thicker atmosphere on Venus. And you'll see maybe a very occasional ray of sunlight hits the surface, but in almost all cases, it gets absorbed in the atmosphere.
The trapped sunlight heats up Venus's atmosphere, and any sunlight that reaches the surface worsens the situation.
So here we are on Venus, our hot surface radiating infrared. And is it making it out into space? Generally, no. Not only is it getting absorbed into the atmosphere, but some of it is bouncing back to the surface. And so on Venus, the infrared radiation is trapped by the thick atmosphere, and the surface and the atmosphere end up heating up.
The process resembles what's happening on Earth, but on Venus, it's out of control. Earth's twin is now the hottest planet in our solar system, even hotter than Mercury, the planet closest to the Sun. Venus is the poster child for climate catastrophe, devastating global warming, and a cosmic hellhole. If Earth were nearer to the Sun, it would look like Venus.
The major difference between Earth and Venus in terms of the evolution of the planets is all about Venus being closer to the Sun. We think that they formed kind of as identical twins, and then it was a different sort of experience of growing up in slightly different neighborhoods closer to the Sun and farther from the Sun that led to this huge divergence we see today.
Life on Earth may be a lucky break, but in the end, we share the same fate.
If you think of the long-term future of the Earth, Earth will go the direction of Venus because the Sun is heating up. And I'm not talking about on a short time scale. If we think about billions of years in the future, really, cosmological timescales, then Earth is destined to end up like Venus.
Scientists long guessed Venus was once like Earth. Venus Express has shown how it evolved into a barren world. More revelations lie beneath the clouds. On the surface, the clouds look calm. But when the spacecraft switches on its infrared thermal imaging spectrometer, its images show how the scene transforms. Violent storms rip across the planet. At the poles, monster cyclones churn the atmosphere. Storm systems that make Earth's worst weather look like a breeze. As scientists study this mysterious planet, they make a startling observation. While Venus rotates slowly, its atmospheric winds travel fast. Venus Express observes winds circling the planet in a mere 4 Earth days. That's 60 times faster than the planet's rotation speed. Scientists call this superrotation. If Earth were like Venus, winds would whip around the planet in just 30 minutes. A speed of 50,000 miles per hour.
When you think about the rotation of the Earth, you've got the rotation rate of the solid planet, 24 hours, and then the atmosphere sort of going along for the ride. But with Venus, it's almost as if the atmosphere doesn't really care what the solid surface is doing. It's got a mind of its own and is rotating much faster than the solid surface.
On Earth, wind speed nearly matches rotation speed. So why do Venus's winds travel so much faster than the planet spins? The answer lies in the clouds. On Venus, the cloud layer is up to 12 miles thick. So thick, only a small amount of solar energy reaches the surface. Much of this energy is retained in the upper clouds, 40 miles above the surface. This energy starts the clouds moving at breakneck speeds. Because Venus is closer to the Sun than Earth, the greater the solar energy in its clouds, and the greater the wind speeds. Winds rare on Earth, over 200 miles an hour, are typical on Venus. Venus Express is equipped to solve a riddle found by an earlier mission. A vortex at Venus's North Pole, similar to vortices on Earth. We call them hurricanes. On Earth, they form when warm, moist air from the ocean is heated by the sun and rises to form clouds. As more energy enters the system, the clouds start to spin, creating a hurricane. But Venus has no warm oceans for fuel. So what powers its hurricanes? Venus Express swings down to the southern hemisphere for a closer look. What it finds blows scientists away. A vast hurricane-like vortex, 1,200 miles wide and 13 miles deep. 4 times larger than the largest hurricane on Earth. Not one, but 2 rotating eyes. Scientists believe the cause of the vortices is not only super fast winds, it's the very motion of the planet.
A huge vortex is caused by all the air flowing in from the equator, and then it has to sink somewhere, which causes this enormous vortex, which is some 2,000 kilometers across.
Wilson believes air from the equator flows to the poles, where it's sucked down to form the vortex. But this air doesn't move in a straight line. The planet's rotation deflects its motion. He suggests this process, called the Coriolis effect, produces the giant vortices.
Let's explain the Coriolis effect using this rotating table. It's the same for a rotating planet. If I let this ball roll across the table, you'll see that it runs in a straight line. And that's because you, the observer, are stationary. You're not rotating with the table. Whereas if, on the other hand, we switch to a camera angle or another observer who's rotating with the planet, this ball will appear to travel in a curved trajectory. So if the observer is rotating with the planet, then it appears that objects experience a force to the right. And this works not only for balls, but also for parcels of air in the atmosphere. If the air at Venus is heated at the equator and moves towards the poles, it's then bent towards the right if it's in the southern hemisphere, or towards the left if it's in the northern hemisphere.
As the winds move toward the poles, the Coriolis effect makes them spin, which creates the vortex. Wilson's theory seems logical. Vortices also occur at Earth's poles. But while Earth's polar vortex is relatively stable, the double-eyed monster on Venus is an ever-shifting whirlwind. To find out what makes the vortex so chaotic, recreate it. Wilson uses water to simulate Venus's atmosphere.
We've got the rotating atmosphere simulated by the rotating tank, and then we've got this thin ring here which spins at a different speed, faster than the rest of the atmosphere. And what we find is that the flow in this region is unstable. It sort of oscillates in and out. And we think that's quite representative of what happens around the edges of the polar vortex on Venus.
When Wilson adds dye, his simulation reveals the shifting shapes at the edge of the vortex. These chaotic winds show the power of Venus's atmosphere. But vortices aren't the only bizarre weather. On June 9th, 2006, Venus Express discovers an eerie phenomenon. The spacecraft detects an intermittent disturbance that sounds like a whistle. A brief, low-frequency electromagnetic burst. This is the actual recording. To anyone else, baffling. But to the mission team, a revelation. The signature of lightning. UCLA's Professor Christopher Russell has long believed lightning occurs on Venus. The spacecraft's discovery presents a riddle. On Earth, water drives thunderstorms. Warm, moist air collides with cold air. Water droplets and ice crystals rub together, creating positive and negative charges. The electrical buildup discharges as lightning. Venus's atmosphere has little water. Most of it has been stripped away by the solar wind. So what else could produce lightning? Thanks to data from Venus Express, a controversial theory gathers new weight. Russell's candidate for the cause of lightning? Clouds of sulfuric acid. On Earth, sulfuric acid clouds form when sulfur dioxide is released from volcanoes and mixes with water vapor. The same thing happens on Venus. 2 decades ago, Project Magellan, the first spacecraft to map Venus, discovered widespread evidence of a volcanic past. Over eons, volcanoes released trillions of tons of sulfur dioxide. Some remained as a gas. The rest mixed with water vapor to form sulfuric acid clouds. The speeding winds energize these acid clouds and create ideal conditions for lightning.
We think now that it's sulfuric acid clouds and Venus's winds, and the winds can then provide the energy source in the cloud for the charge separation.
Sulfuric acid does on Venus what water does on Earth. Acid drops rub together and create positive and negative charges.
I was looking for lightning and looking for the proof that it really existed, and to find it is like a personal victory.
The discovery of lightning is electrifying. Lightning is an ingredient of life. An even greater shock was in store. The hellish planet might not be dead. Eons ago, Venus's volcanoes spewed out vast clouds of sulfur. But today, tests show the level of sulfur is fluctuating. Since volcanoes discharge lots of sulfur only when they erupt, the fluctuations mean one thing. The volcanoes on Venus must still be active. Scientists have found active volcanoes in only a few places besides Earth. In 2007, the New Horizons probe captured an eruption on Io, one of Jupiter's moons. To find active volcanoes in the inner solar system is big news. It means Venus may not be a dead rock, but a living planet. Venus Express takes a closer look. The probe exploits the infrared windows to peer through the clouds. Below, mountains and valleys, smooth plains, impact craters, and flat-top features like pancakes, all made of lava. 85% of Venus's surface is paved with lava. Why so much? Puzzled scientists. To understand Venus's vast lava fields, scientists look to its calmer twin. Earth's crust is made up of interlocking tectonic plates that drift over its liquid mantle. Most of our planet's volcanic activity is found where these plates move together or pull apart, allowing heat from the core to escape. No mission has ever found evidence of plate tectonics on Venus. Its crust is solid. Without plate tectonics to cool Venus, scientists suggest heat from the core built till it couldn't be contained. Then virtually the whole planet erupted, releasing so much lava, it recycled the crust and resurfaced the planet.
This is a demonstration of the Venus resurfacing. We're going to demonstrate with some pudding in a pan over a hot plate. And this heat from the hot plate represents radioactive heat from the inside of Venus. And here we're seeing the first signs of the interior heating the crust on the surface. And that crust is stagnant. It's not moving, it's keeping the heat inside. And perhaps at this moment the surface might even crack in some places, and the molten material, the molten rock under the crust would erupt and flow out onto the surface, covering up all the craters and all the mountains. And at this point, we can see several small volcanic eruptions along those fissures.
Scientists date the resurfacing to 500 million years ago. A slow process that took tens of millions of years. This cataclysmic series of eruptions released trillions of tons of sulfur dioxide and carbon dioxide replenishing what the solar wind removed. Yet surveys of Venus reveal not all the planet was resurfaced. Rocks in the highlands are much older than the lava covering most of the planet. They offer a clue to conditions in the distant past. Kevin Baines discovered these rocks weren't born on dry land.
On Venus, most of the rocks are basalts. They're made out of volcanoes spewing out their lava. But we have found a very interesting result in the last few months. That is, the highlands are special. On the highlands, the tall mountains of Venus, we're finding evidence of rocks that were created in the presence of water, as if billions of years ago they were formed perhaps in an ocean, and then geologic processes have risen them up since then.
The rocks provide hard proof that Venus once had oceans, which raises a provocative question. On Earth, life began in the oceans. The other ingredient to kickstart life is lightning. And lightning occurs on Venus. If Venus had water and lightning, did it once have life? Scientists have plenty of proof that Venus and Earth were once twins, and that Venus had two of the ingredients of life: water and lightning.
Lightning is important because it's something that produces exotic species. For example, nitrogen and oxygen combined to produce nitrogen oxides, which are important for life and important for producing chemicals that can't be produced any other way in a planetary environment.
With water and the means to kickstart evolution, perhaps Venus once had life, and maybe still does. The first clues arrive from Venus Express. 155 miles above the surface, a camera is switched to ultraviolet. Unlike infrared, the shorter wavelength of UV is scattered by Venus's cloud layer, enabling the scientists to explore the upper regions of the atmosphere. Their images reveal intriguing dark markings where more UV is being absorbed. This shows that something besides sulfuric acid is trapping sunlight. The mission team calls the dark areas absorption patches.
There's been great interest in the ultraviolet absorbers on Venus. They absorb about half of the sunlight that's hitting the planet. They're in the clouds of Venus, and it's been suggested that they might be associated with life forms.
Life forms like microbes, living in hurricane-force winds and sulfuric acid clouds, using UV light in some weird photosynthesis. But what kind of life could survive such conditions? Biologist Lynn Rothschild studies organisms that live in extreme environments. She has discovered microbes called extremophiles thriving in some of the harshest conditions on Earth, like Yellowstone National Park. With the highest concentration of thermal springs in the world, it opens a window into how life might survive on Venus.
What you see behind me is really ground zero for where people started to understand organisms that could live in extremely acidic conditions. Before that, people thought conditions like lemon juice would be totally outside the realm of where a living organism could be.
These geysers, powered by volcanoes, mimic conditions on Venus: hot and acidic.
This stream is just phenomenal. It's about pH 3, it's about 40 degrees centigrade. A little hotter than warm to the touch. Actually, it's fairly warm to the touch. What you see in here is almost a pure culture of some red algae. I know it looks green, but they are actually red algae that don't have a red pigment.
Extremophiles like these can survive in battery acid and temperatures above boiling point. These organisms have evolved to survive not only the heat and the acid, but levels of other chemicals that would kill most life.
These particular organisms, Cyanidium, are really neat because not only do they live at low pH and in warm temperatures, and they photosynthesize, but they've been shown to be able to survive in pure CO2, pure carbon dioxide. Even Venus doesn't have as high a carbon dioxide level as that.
The organisms show life can survive hot, acidic carbon dioxide-rich environments, like Venus. If life can survive in Yellowstone, why not on Venus? Scientists believe the surface itself is too savage. Temperatures reach 900 degrees, and the pressure is bone-crushing. But not in the clouds. 30 miles up, temperatures reach only 176 degrees, much closer to the kind of heat microbes endure on Earth. Could life have begun in Venus's ancient oceans? When the water evaporated, the microbes may have gone with it. Here, in the cooler acidic clouds, they could survive. But how can life exist without water?
There is water vapor up in the clouds in Venus, and we have some indication that organisms on the Earth, for example, lichens, can use water vapor as their source of water. So that's pretty encouraging for life in the clouds, at least in terms of having water available.
To see if life exists in moist, acidic clouds, Rothschild collects air samples above a hot spring. The acidic steam mimics the clouds of Venus.
Well, I can see a little green on the mouth here. That's encouraging. Maybe there really is something in there.
Analysis shows microbes can exist in hot, acidic steam, suggesting life may survive in Venus's clouds. To further test the theory, Lynn sends organisms high into the atmosphere. She's launched a whole spectrum of microbes. Some to over 100,000 feet. A zone where temperature and pressure drop so low, most life would die.
Okay. Now let's hope we put enough in it.
Many of her subjects survived. Some researchers have even found organisms that can reproduce high up in the atmosphere.
The clouds on Venus are continuous and long-lived. So you could imagine creatures that live in the clouds and reproduce in the clouds and even seed other cloud particles. And they're not going to last forever because they're going to fall out, but as long as they last long enough to reproduce themselves, then you could have a self-sustaining colony of life in the clouds.
Research shows life in hot, acidic clouds is theoretically possible. Perhaps microbes live in the clouds of Venus, hidden in those strange dark patches. Venus Express has traveled 87 million miles around the planet and completed 100 weeks of collecting data. It proved that Venus once looked like Earth. A habitable climate, vast oceans, perhaps even life. But too near the sun, Venus was doomed. Earth blossomed, Venus burned. Yet even here, life may thrive. maybe tucked in blankets of clouds. We may have to wait years for the secret to be revealed. But someday, another mission to Venus may find the holy grail of space. Life beyond our world.
Abundant life. It's the hallmark of our planet. But it's water that makes us unique.
Liquid water is the essential environmental requirement for life on Earth. So when we look for life elsewhere, we start first by looking for liquid water.
Our search has taken us to an alien world that seems to defy the laws of physics. A place where water can't exist, but shows us evidence that it might.
We have what we in science call an anomaly.
NASA's Phoenix lander will find out if life is possible on this desert planet. Welcome to Mars, the water world.
Load relief kit crate is in, vehicles responding. Vehicles recovering very nicely from the liftoff transients.
August 4th, 2007 at 5:26 a.m. This Delta II rocket blasts off from Cape Canaveral. In its nose cone is NASA's first robotic Mars scout, the Phoenix lander.
At this point, we have a strong signal from Phoenix via Odyssey.
At NASA's Jet Propulsion Laboratory in Pasadena, California, engineers monitor the progress of the $500 million mission.
All stations, we have confirmed crew stage separation and UHF signal acquisition via Odyssey. Atmospheric entry on my mark. 3, 2, 1, mark.
The new generation lander enters the final phase of its 400 million-mile journey to Mars.
1 minute since LOS, standing by for signal reacquisition.
Phoenix will search the Arctic plains of Mars for the building blocks of life, including carbon, nitrogen, and most importantly, water.
Touchdown detected. Landing in sequence initiated.
Phoenix intends to prove that life on Mars is, or was, possible. If it does, then life on Earth is not unique. This is a test simulation, but on May 25th, 2008, the team at JPL attempts this for real.
Primary objective of Phoenix is to explore the Martian Arctic and to determine whether or not conditions for life are there today or existed in the past.
If Phoenix finds what it's looking for, it will change our understanding of the solar system. If there's life on another world, it could mean that the universe is teeming with it, that the aliens of our science fiction could be a reality. Phoenix might even find them. But finding the signs of life on a planet millions of miles from home is an incredibly difficult challenge. The lander hasn't been designed to find life directly. It's been built to find the necessary ingredient for it: water. Chris McKay is a planetary scientist at NASA's Ames Research Center.
When we look at life on Earth, we see an enormous diversity. Organisms that do all sorts of different chemistry, live in all sorts of different environments, but the one thing that all organisms on Earth have in common is a requirement for liquid water. So naturally, when we look for life elsewhere, we start first by looking for environments that had liquid water.
Here on Earth, wherever there's water, there's life. Even in temperatures as extreme as 14 degrees Fahrenheit, organisms can survive. So if we find signs of water on Mars, we might find life too. But why are we looking on Mars? Professor of Geomorphology Vic Baker explains.
30 years ago, a spacecraft called Mariner 9 produced about 9,000 pictures, many of which showed large channels and valleys. And it was very obvious that these channels and valleys are directly analogous to what we see on the Earth formed by water.
Scientists are stumped by these images. It definitely looks like water erosion. But as far as they know, there is no water on Mars. Its atmosphere is too thin to support it. The air pressure on Mars is less than 1/100th of the Earth's, which means the air on Mars's surface is the same as it is here on Earth at 110,000 feet above sea level. That's 20 miles high, nearly 4 times the height of Mount Everest. Scott Rafkin is a planetary atmosphere specialist at the Southwest Research Institute in Boulder, Colorado.
It's fairly common knowledge that if one goes camping or hiking and you go up to higher altitudes and you go to boil your water, as you go higher up, it boils at lower and lower temperatures. That change in altitude is what you're really doing is changing pressure. As you go up in altitude, the pressure is becoming less and less. And so what happens is that as you go higher up, it becomes easier to boil water. You don't need to raise its temperature as much.
This experiment shows the effects of Mars's atmospheric conditions on water. Gradually removing air from the chamber reduces the pressure. At first, nothing happens. But when the pressure drops to the equivalent of Mars's atmosphere, the water boils. Water normally boils at 212 degrees Fahrenheit, but at this low pressure, it boils at room temperature. On Mars, this happens at just 50 degrees.
The stability of water on any planet is tied to primarily the pressure. And the pressure on Mars is so low that if one could have liquid water sitting out on the surface, it would simply boil.
Mars's ultra-thin atmosphere creates another problem for water to exist here. There's not enough of it surrounding the planet to insulate it. Mars is ice cold. At its warmest, it's just 70 degrees Fahrenheit. At its coldest, the temperature drops to minus 225.
Now, of course, on Mars we have another problem, which is that it's very, very, very cold. So even if one had the higher pressure so that the water wouldn't boil off, it would just freeze solid, like a rock.
The existence of these channels and valleys that appear water-carved baffles scientists.
The question is, how do you have these two things? How do you have a planet that is cold and dry with a thin atmosphere, and yet clearly, in its past, had flowing water?
Over the years, scientists have offered many theories to explain the features seen on Mars's surface.
People have suggested, well, maybe it's carbon dioxide liquid, or maybe it's lava, or maybe it's wind. Well, wind, lava, carbon dioxide could have formed many of the features we see on Mars, but they can't explain all the features.
And for the past 30 years, this has been the major source of science controversy. And it's the reason that the current NASA program is sort of directed with this euphemism, follow the water.
Using the latest science provided by Phoenix, NASA hopes to prove once and for all that they were made by liquid water, a substance that shouldn't exist on the planet. But the debate is growing more controversial. In June 2000, scientists got very excited about these images taken by the Mars Orbiter camera, a probe that has been circling the red planet since 1997. This one was taken in 1999. And this is of the same location in 2000. The images clearly reveal a changing landscape. To geologists like Vic Baker, These recently formed features look strangely familiar.
On Earth, we would call them gullies. They're sort of on the scale of hundreds of meters, no more than a kilometer. They're patterns like the veins in a leaf or branches in a tree that result from how water falling on the surface organizes itself into larger and larger drainages.
These gullies and alcoves seem to have been recently formed by water. They have appeared in the southern hemisphere of the planet, on slopes that get the least amount of sunlight during each day, one of the coldest parts of Mars. Their similarities to gullies formed by water here on Earth defy logic and the laws of physics. So what created them? Did water flow across Mars in its past? And is it still flowing today? On May 25th, the Phoenix lander, NASA's $420 million mission to Mars, touches down on the red planet to answer two questions that have vexed scientists for decades. Is there water, and could there be life? At the heart of this debate lies this rock that landed on Earth from Mars. Discovered in 1984 in the Antarctic, it's 6 inches long and weighs over 4 pounds. It's called the Allen Hills meteorite, and it's one of just 34 Martian rocks that have been found here on Earth. Johnson Space Center astrobiologist Dr. David McKay has studied this meteorite for more than 10 years.
Allen Hills is unique among the Mars meteorites because it's so old. It is by far the oldest of the known Mars meteorites. And furthermore, with an age of 4.5 billion, it is older than any rock ever found on the Earth.
McKay believes it contains proof life was possible on Mars. Using high-resolution scanning electron microscopes, he examines the meteorite and discovers tiny globules of iron and magnesium carbonate. Elements almost certainly formed and deposited by liquid water.
Carbonates are significant because they show that not only was water there, but it was relatively low temperature.
McKay is convinced that this proves Mars's atmosphere was once very different and could sustain flowing water, so the conditions for life were present. By radioisotope dating the carbonate globules, McKay comes up with a figure. Water flowed on Mars 3.9 billion years ago. NASA's current crop of rovers scouring the planet backs up McKay's findings. This is Meridiani Planum, the landing site of the rover Opportunity in January 2004. It's a dusty area the size of Oklahoma. Photographs relayed back to Earth reveal the soil is littered with countless BB-sized rocks. NASA scientists nicknamed these puzzling objects blueberries. On Earth, similar deposits form, but only in standing water or hot springs. Geologists have uncovered blueberry-like clusters dating back millions of years in Lake Superior and near the hot springs of Yellowstone National Park. Their discovery on the vast plain of Meridiani Planum suggests this area was once saturated with water, or was even an ancient lake. In fact, closer examination of the surface of the planet reveals that much of it was once a water world. These images, taken by a high-resolution stereo camera aboard the Mars Express spacecraft, reveal Mars's watery, almost Earth-like past. This is a large depression called Ionic Chaos, and next to it an outflow channel called Ares Vallis. They're the remains of Martian river systems. And to planetary geologists like Jim Rice, clear evidence of ancient catastrophic floods.
We took every river on Earth and put it in one spot, had them flowing at the same time. Some of these flood channels on Mars, when they were in full force, were 20 or 30 times bigger than those.
What was it that happened in the Martian past? Why do we have a planet today that is very cold and dry and gives every indication that we don't have liquid operating on its surface? Why in the past did we form these channels?
If Phoenix can figure out if water flowed across the surface of Mars in the past, it will explain the valleys and canyons we see today, and take us one step closer to discovering if water still exists, and even life. Now the Phoenix mission can confirm what the experts suspect.
It must have been warmer, at least for some period of time, so that we could have liquid water on the surface. And the pressure must have been higher than it is now, or the water would have boiled away.
Early in its evolution, Mars was much warmer. In fact, it was boiling. $4.6 billion years ago, our sun bursts into life, and our solar system forms around it. Both Earth and Mars are huge balls of lava, boiling at over 12,000 degrees. Slowly, they begin to cool. Dr. Peter Smith heads up the Phoenix mission from its base at the University of Arizona.
Earth and Mars formed at about the same time, but Mars is only half the diameter of the Earth, and therefore it would cool more rapidly.
Mars's size proves to be the crucial factor in its transition from a fiery molten ball into a warm and wet planet. In this demonstration, two globes are used to represent Mars and our own planet, Earth. These scale models exactly replicate the difference in size of the two planets. Mars, shown here on the left, has half the diameter of Earth. Both spheres have been heated to the same temperature. Now they are cooling naturally. Infrared time-lapse clearly shows how quickly the smaller sphere representing Mars cools. Mars was cool enough for water at a time when Earth was still a red-hot ball. This water comes from comets. The early solar system is littered with large asteroids and comets made up of ice. As they crash into the planets, the ice melts. On super-hot Earth, the water boils away instantly. But Mars is cool enough to hold on to the huge quantities of water released by impacts.
And in that cooling, liquid water would be stable on the surface long before it would be stable on the Earth. And so during that period, it may be that you had rains and valley systems and lakes and all kinds of Earth-like situations.
Scientists believe that 3.9 billion years ago, Mars had the climate and atmospheric conditions to support liquid water, an essential ingredient for life.
Now, in the early days of the history of our solar system, this planet, the Earth, was not a good place for life to develop. We had noxious gases all over the places, volcanoes belching out all sorts of stuff. Mars was warm and wet and wonderful. It was the most likely place for life to develop.
Today, Mars is no longer warm, but is it wet? Understanding what happened to Mars's water is the primary goal of the Phoenix mission. Its success might hold the key to answering a 30-year-old question. Does water still exist on Mars? Scientists are now certain that Mars was once warm and wet. Pictures of ancient riverbeds, blueberries on the surface, and carbonate globules inside the Allen Hills meteorite confirm this view. But if there was water billions of years ago, where is it today? The question of whether water still exists on Mars will only be settled when NASA physically finds it. And that's the job of the Phoenix lander. It's being sent further north than any previous mission, to a site chosen because frozen water might sit below the surface. In 2003, NASA's Odyssey orbiter produces this image. Using its gamma-ray spectrometer, the spacecraft maps levels of hydrogen in the upper 3 feet of Mars's surface. Since high levels of hydrogen indicate the presence of frozen water, scientists think that these blue and violet areas, the densest concentration of the element, reveal an enormous frozen reservoir.
In fact, there's so much water in the polar areas and the nearby ice terrains that if you spread that water around the surface of Mars, that alone would inundate the surface of Mars on the order of 6, maybe 10 meters deep.
Phoenix's first job is to confirm that the hydrogen-rich area is in fact made up of water. Then scientists can begin to piece together the chain of events that lock the water under the planet's surface. Maybe then they'll begin to understand how the recent wet spots appeared. Some scientists believe they are a remnant of ancient climate change. Mars cools much more quickly than Earth, allowing water to exist on its surface. But a drastic shift in atmospheric conditions means it can't hold on to it. Earth's large molten core generates a magnetic field which protects our atmosphere from solar radiation. But Mars's small core cools so much that it no longer produces an effective shield. Solar wind blasts away its atmosphere and most of its water. Pressure falls and the temperature plummets. Whatever water it has boils away or freezes solid, leaving the Mars we see today, a frozen world. Up until recently, scientists believed that Mars's core is so cold that it is no longer able to crack and move the planet's surface.
The Earth releases a lot of its heat continuously by a process that's known as plate tectonics, where the continental masses of the planet are actually shifted by the formation of new crust in the ocean basins. Mars doesn't have that.
But the discovery of the gully features, the wet spots, suggests that Mars's core hasn't cooled as much as they thought.
Because it can't release its heat as efficiently as Earth, one idea is that this heat builds up with time, and episodically there's kind of a burst of heat release that will melt the ice in the Martian permafrost. And that water comes onto the surface, perhaps associated with gases that change the composition of the Martian atmosphere to a greenhouse kind of condition. So you have a temporary, unstable state where Mars is warmer and has water on the surface.
These small flash floods could be the wet spots that dot the surface of the planet.
It's natural to suspect that maybe this volcanism that has happened in recent history and the water activity are somehow related. But this is one of the mysteries we're trying to investigate, and I think it's one of those that the Phoenix lander may be able to shed some light on.
By finding ice and analyzing its composition, the Phoenix lander is designed to map the planet's ice history. It will tell us how geothermal activity and atmospheric change have affected Mars's ancient water.
Load relief kick rate is in. Vehicles responding. Vehicles recovering very nicely from the liftoff transient.
Phoenix's quest represents a journey into the unknown.
Up to now, all of our exploration of Mars has been superficial. We take pictures from orbit, we drive around on the surface, and maybe we dig down this deep, either by dragging it with the wheels or with a little arm or something. We maybe get down this far, and that's it.
But Phoenix is set to change this. It's designed to endure Mars's northern latitudes and to analyze subsurface ice. NASA hopes its findings will throw light on how water interacts with the geology of Mars, the key to unlocking the story of past atmospheric change. In order to achieve this goal, it's been built to do something no other Mars lander has done before.
Phoenix is going to arrive on Mars and land and dig.
A sophisticated robotic arm will dig down 3 feet into the frozen subsurface to where the layer of water is believed to be. At nearly 8 feet, the arm is the most important tool on the lander. It's designed to dig trenches, scrape ice, and deliver samples to other instruments on the lander's deck. No one knows the capability of this arm better than Phoenix's lead scientific investigator, Dr. Peter Smith.
The robotic arm in digging on the surface is doing something very difficult because it's being controlled from 100 million miles away. And so the interaction of using the arm and seeing through the eyes of a camera is not simple. It's like going out to drive a semi-truck with never having driven one before. The truck works, but learning how to shift 18 gears is not so easy.
If working properly, Phoenix's robotic arm will drop ice samples into a device called a Thermal and Evolved Gas Analyzer, or TEGA for short. TEGA has 8 tiny ovens, about the size of an ink cartridge in a ballpoint pen. Not unlike this one. Once a sample is successfully sealed in an oven, the temperature is slowly raised at a constant rate. As the temperature edges up to 1800 degrees Fahrenheit, the ice and other volatile materials in the sample vaporize into a stream of gases.
So if you think about what happens in your kitchen when you put, say, some sort of food in the oven and you start to heat it up, it's cooking nicely at 200, 300, 400 degrees. But if you start to crank that oven up 800, 900 degrees, 1,000 degrees, what's going to happen to the organic materials in there? Well, they're going to turn to smoke. They're going to come out, and like in my kitchen, they're going to set off the smoke alarm. And you're going to be doing an experiment just like TEGA.
Roasting the samples of soil and ice at 1800 degrees releases what are called evolved gases. A mass spectrometer will then scan these gases for minute quantities of hydrogen, oxygen, carbon, and nitrogen, the elements of life. But Phoenix's sophisticated instruments do have a limit. Each of its 8 ovens can be used only once. So as it digs down, it will take samples at 8 different depths. NASA hopes to then map the changing character of the ice. Scientists hope these precise measurements will reveal the evolution of water on the planet and possibly uncover the existence of life. To get a head start on the kind of data the lander might send back, the Phoenix scientists set out to replicate their experiments here on Earth. The geology of Mars and Earth is surprisingly similar. Mars is a cold, dry desert landscape of sand and rocks. But both planets share land features like volcanoes, canyons, and valleys. This is the most Mars-like place on Earth, the Antarctic.
Mars, when it was at its warmest and wettest, would have been like Earth at its coldest and driest. That's why, to me, going to the dry valleys of Antarctica is the next best thing to going to Mars.
Here, Chris McKay and Peter Smith are going to do on Earth what Phoenix will be doing on Mars.
The idea is to make the connection between what Phoenix will measure on Mars with what Phoenix would measure in the dry valleys of Antarctica.
They're digging down to ice to see if life, or the conditions for life, exists in this inhospitable terrain.
We go from a surface soil, which is kind of reddish and definitely of a different character than the lower soils, and we're going to measure layer by layer down to ice. We're using instruments on the deck of the spacecraft, and our robotic arm scoops up samples as it digs down and presents them to the science instruments, which analyze them right there on Mars. I think just by looking at these soils here, you can tell that liquid water's been at work. If we could see that on Mars, we have a place where we have a habitable zone and perhaps a place where life could live.
McKay and Smith's analysis of Antarctic ice reveals that life can exist in the sub-zero temperatures found on Mars.
It's really quite phenomenal what we can find in the dry valleys and in the high Arctic, how life can make do with small, transient amounts of liquid water.
These life forms are called extremophiles. They're microscopic bacteria that thrive in extreme environments. They were first discovered 40 years ago in the 160-degree hot springs of Yellowstone National Park. Since then, others have been found living deep under the ocean, in supersaline environments, even in the uranium-rich pools of water in nuclear power stations. But it's the ones that live in the sub-zero temperatures of Antarctic ice that interest the Phoenix team. They reason that if microbes can be found here, then why not on Mars? So if Phoenix finds ice, it might just find evidence of life locked inside it.
The other remarkable thing about polar deserts is how well ice and cold in general preserves evidence of life. We know that you can go up into permafrost in Siberia and dig out mammoths that have been frozen for 10,000 years or more. On Mars, we're hoping for the same effect. We're hoping to find, frozen in the ice on Mars, evidence of life that may have been preserved maybe for millions, but maybe even also for billions of years. Frozen micro-Martian mammoths, if you will.
Not only will Phoenix detect changes in atmosphere and temperature, it has the ability to identify organics, crucial to the search for life.
Our mission was designed specifically to touch water in the form of ice and to try and understand the properties of that ice, its history, its interaction with the soil, its interaction with the atmosphere, and really explore the question of is there or was there ever life on Mars?
By analyzing the soil samples, Phoenix might finally identify the building blocks of life: carbon, hydrogen, oxygen, and nitrogen on Mars.
And if we saw the organic materials, energy sources, and liquid water present in the past, we would say this is a habitable zone, and perhaps some sort of Martian life could live there.
With the Phoenix mission, NASA's 30-year search for water on Mars could finally come to an end. And by following the water, it might just find life. May 25th, 2008, NASA's Phoenix lander reaches the end of its 9-month-long journey to Mars. It now begins the hunt for life, or at least an environment that could have once supported life. But does NASA really think it can find this on the frozen wastelands of Mars? The answer is yes. This is because of an accidental discovery made by the rover Spirit.
Spirit's most significant scientific discovery came 1,200 days into its 90-day mission.
In 2007, a moving part on Spirit malfunctions. The failure leads to the best evidence yet that Mars was once capable of supporting life.
The right front wheel on Spirit doesn't turn anymore. It's failed. But the one good thing, the silver lining here, is that as we drive and we drag that wheel through the soil, we dig a trench. And every now and then, something interesting will pop up in the bottom of that trench.
X-ray analysis of a patch of soil churned up by the stuck wheel yields unexpected results. It is composed of about 90% pure silica.
That was just a complete unexpected discovery, pure serendipity, and frankly, if the right front wheel had been working properly, we might not have found it.
This $320 million breakdown reveals more evidence of water. On Earth, high levels of silica occur in only two places: hot springs or fumaroles. Both environments bubble with water and life.
The thing that's important about the silica discovery is that you can go to hot springs and you can go to fumaroles on Earth, and in both instances they're teeming with microbial life.
Spirit has discovered evidence of a habitable zone on Mars, a place where extremophiles like those on Earth could have thrived, and may even exist today. What's more, the idea of Martian life is backed up by the 4 billion-year-old Allen Hills meteorite. Structures inside it reveal what some believe is the first real evidence of Martian life forms. David McKay heads the team that made the discovery.
We discovered in Allen Hills what we concluded was strong evidence for past life. That evidence consisted of, number one, some little tiny fossil-like features that are similar to fossils known to occur on Earth. Number two, we found that there were crystals made of an iron oxide, which are also always associated with bacteria on Earth.
McKay and his team believe that the Allen Hills meteorite is proof that life existed on Mars. When they announced their discovery in 1997, most scientists were skeptical.
The discovery of fossils in the Martian meteorite was always problematical. They weren't really biological structures, they were just little round and little oval-shaped things. And people quickly realized that if you pick up any piece of rock or dirt and examine it at that scale, you often see little round and little oval-like structures that have nothing to do with biology.
But Spirit's discovery of silica on Mars has reopened the debate about Martian microbes. If extremophiles can be found in similar environments on Earth, then why not on Mars? Will Phoenix find the evidence that backs up McKay's belief that life existed on Mars? If it does, the implications will be profound.
You may think that if we find life on Mars and it's just microbes, who cares? Why is that important? But within those microbes could be the potential for all of the richness and complexity of life like we see on Earth. In the same sense that an acorn is an oak tree, a single organism on Mars could represent the potential for complex ecosystems for animals and plants and even human-like intelligence. Even if on Mars that seed didn't grow to its full potential, if the acorn didn't become an oak tree, it's still interesting because it tells us that on other worlds, on other stars, it would have fully developed. We're not alone.
It's an astonishing prospect, one that the Phoenix mission is poised to solve.
Well, when Phoenix lands down on Mars and sends back its first signal that it lands successfully, I will breathe a 5-year-long sigh of relief.
But before NASA's latest probe can answer tough questions about life and our place in the universe, it first faces its biggest challenge: descent and landing. NASA's latest mission to Mars will try to answer some fundamental questions about the red planet and the nature of life in the universe. When Phoenix begins searching ice for traces of life, it takes us closer to understanding our place in the solar system. Is life on Earth a quadrillion to one miracle? Or does it appear wherever and whenever the circumstances are right? Before it can answer these questions, Phoenix has to safely get to Mars. NASA's probe approaches the planet at 74,000 miles per hour.
Station TDLCom. At this point, we have a strong signal from Phoenix via Odyssey.
On May 25, 2008, at 7:46 p.m. Eastern Standard Time, the team at JPL begins slowing the spacecraft down for a soft landing on the planet's surface.
It lost the X-band signal from the DSN, does indicate an expected cruise state separation.
This man is responsible for bringing its speed down from 74,000 to 5.5 miles an hour. He's Gentry Lee.
The risky part of the mission begins as we near Mars. When we hit the top of the atmosphere, the process of slowing down begins. And in that 6 to 7 minutes, we slow down from tens of thousands of miles an hour to single digits miles per hour so that we can land softly.
It's a process that involves 3 distinct phases. They're called EDL: entry, descent, and landing. Each is potentially deadly. Friction from the atmosphere slows the craft to about 750 miles per hour.
First, you have a heat shield, which takes this enormous potential energy and converts it into heat. That's 99% of the deceleration. Then when it's done, out pops a parachute, and it takes another 99% of the speed out.
The parachute's performance is crucial to the success of the mission. Up to this point, Phoenix's EDL is identical to any other Mars mission. But unlike the rovers before it, Phoenix has no airbags to cushion its landing. Instead, it uses 12 descent rockets clustered around the hull to slow down. In the final 34 seconds of descent, they fire rapid pulses, carefully timed to bring the lander down at 5.5 miles an hour. If Phoenix's engines fail, its terminal descent will have been just that. For controllers, this is one of many things that could have gone wrong.
And then, of course, will come the moment when it's too late to even ask any questions.
Standing by for possible flashing blackout.
Did the radar see the ground properly? Did the computer interpret the information properly? Did the pulsing engines do what they were supposed to do? I can't wait. Will somebody please tell me now?
On May 25th, 2008, at 7:53 p.m., Phoenix starts its descent.
Ground relative velocity 90 meters per second. Touchdown signal detected. Landing sequence initiated.
The landing is a success. For the team, this is the culmination of 5 years' hard work, and yet the mission is just beginning. These are the first images Phoenix sends back to Earth. The search for life on the red planet begins. Saturn, one of the most mysterious planets in our solar system. Now the Cassini-Huygens mission is exploring this enigmatic world and its moons. For the first time, it allows scientists to see what lies below Saturn's upper atmosphere and investigate the origin of its incredible rings. A probe touches down on the largest moon, Titan, to search for a world like our own and the possibility of life.
Five, 4, 3, 2, 1, and liftoff of the Cassini spacecraft.
4:43 a.m. October 15th, 1997. An 1,100-ton Titan 4B rocket launches from Cape Canaveral. It carries with it Cassini-Huygens. Its destination lies almost 900 million miles away at the awe-inspiring planet Saturn. A huge gas giant orbited by at least 60 moons. Saturn is the second largest planet in the solar system, over 750 times more massive than Earth. It's a gassy world without solid surface. The last mission to this mysterious planet launched over a quarter of a century ago. The Voyager spacecraft sent back these images, showing a planet shrouded in thick banded cloud. Onboard infrared cameras spot what looks like storm activity beneath the haze. Something big is brewing on Saturn.
The problem with Voyager missions is that they were flyby missions. They were one-time snapshots.
Voyager can't stop to investigate. Its flight plan is fixed. Scientists can only gather limited data. Voyager 1 also skims the atmosphere of Saturn's largest moon, Titan. Scientists are shocked at what it finds. Its instruments detect organic compounds in the atmosphere. These are similar to the compounds that provided the raw material for life on Earth 4 billion years ago.
In a way, Titan is a glimpse back in time to processes that may have been occurring on the early Earth that may have led to life.
But once again, Voyager 1 can't stop to investigate. It hurtles off at 39,000 miles per hour into the cold outer reaches of the solar system. The Voyager mission makes tantalizing discoveries, leaving scientists with more questions than answers. They are determined to return to the mysterious moon and take a closer look.
We want to understand our own origins. We want to understand why the Earth came to be the way it is and how life came to develop here.
Scientists believe by unlocking some of the secrets within Saturn and its moons, we could learn how our own world developed and how life began. Cassini is one of the most scientifically advanced spacecraft ever launched. It will explore Saturn's atmosphere using an array of high-tech cameras and sensors. Cassini carries with it a probe called Huygens. This will deploy to Titan, Saturn's largest moon. It will plunge through the thick atmosphere and land on its surface. But first, Cassini must make the long haul through 2 billion miles of space. The mission control team used the gravitational pull of our neighboring planets to slingshot the spacecraft around Venus, Earth, and Jupiter, giving it enough momentum to reach Saturn. After 7 years of flight, Saturn looms into view. Cassini captures this stunning image of the gas giant. But before it can get close enough to begin its detailed exploration, Cassini must pass through the rings. The rings are chaotic and dangerous. Made up of billions of particles of ice and rock, circling around the planet at high speed. Some chunks are as big as houses. The only way through is to navigate a gap between the rings. Dr. Jeff Kuzi is in mission control as Cassini approaches the gap.
The gap isn't something you would see with your eye. So it wasn't exactly like there was a huge, tight tolerance, a narrow, threading the needle kind of a thing.
Tension builds as the high-risk maneuver begins. Cassini fires its rocket engines to position itself and heads for the gap. Its antenna points away from Earth. Communication is temporarily lost. Dr. Larry Esposito waits for the signal to return. The sign that Cassini has made it through in one piece.
Everyone was holding their breath, waiting for the signal to come from the spacecraft to show that it had successfully passed through the ring plane.
Several hours later, they get the signal.
The Doppler has flattened out.
Cassini has made it through.
Once that happened, the silence ended, broke into cheers, applause. People hopped up, shook each other's hands. Some people hugged each other. It was a great moment of success after decades of planning.
For the first time, a spacecraft has entered orbit around a planet in the outer solar system. And for Dr. Tony Del Genio, it's in the perfect position to start exploring this gas giant.
The beauty of the Cassini mission is that for the first time, we get to go into orbit around a planet like Saturn, and for years observe it over and over again from different angles. And by putting that together over this long period of time, finally some of the secrets start to be revealed to us.
The first task is to explore what lies beneath Saturn's thick upper atmosphere. Cassini maneuvers towards the South Pole. There, its instruments reveal an unexpectedly familiar phenomenon. A monster hurricane-like vortex. This actual image clearly shows the storm and its scale.
This feature is more than 1,000 miles across, so many times the size of a real hurricane on Earth. And what you're seeing is a sequence of images showing the clouds rotating around the South Pole.
This is the first hurricane-like storm ever detected on any planet other than Earth. Like hurricanes on Earth, It has an eye circled by a gigantic column of cloud. But this one towers 45 miles high. Around it, winds rage at 350 miles an hour. Cassini's cameras zero in on the high-altitude clouds in the upper reaches of the eye wall. Temperatures here are minus 167 degrees Fahrenheit. The pictures capture what must be a flurry of ice crystals. Scientists are enthralled. Like Earth, Saturn has storms with swirling clouds, strong winds, and even snow.
It definitely snows on Saturn in the upper reaches of the storm systems that we see. I think we're pretty confident that there would be large ice crystals. When you got down much deeper than we can see to in the images, then we would expect actual liquid water rain to be falling out of the bases of those clouds.
On our planet, hurricanes are fueled by the ocean and ultimately the sun. Saturn is far too distant to draw the kind of solar power its monster storms need. So what drives them?
When you get into a gas giant atmosphere like Saturn, once you get a wind going, you can maintain it for a long period of time without a solid surface underneath it to dissipate it very quickly. But still, slowly over time, if you didn't somehow put energy into the system, the winds would still dissipate.
Now scientists investigate the theory that the energy for the storms comes from deep inside the planet. It's a theory they've never been able to prove. But at a laboratory in France, an extraordinary experiment is trying to verify its basic principles. Cassini captures these images showing a monster storm on Saturn. A gigantic hurricane 2/3 the diameter of Earth rages at the planet's south pole. Winds encircle the central eye at over 350 miles an hour. Scientists want to know what fuels these storms. Saturn is too far from the sun for them to be driven by solar energy. The power source must lie elsewhere. Many scientists believe it comes from deep within the planet. At the Coriolis Laboratory in France, astrophysicist Peter Reed searches for evidence to support the theory. He is using an internal heat source to recreate Saturn's turbulent atmosphere.
The overall objective is to try to come up with an understanding of what processes actually drive the winds and organize them into banded structures and into these sets of alternating eastward and westward jet streams on Saturn and the other gas giants.
Inside this huge rotating tank is almost 40,000 gallons of fluid. This acts like Saturn's gases. A heater sits in the base of the tank to simulate a heat source deep inside Saturn. Suspended in the fluid are tiny light-sensitive particles.
So these particles act basically like clouds in Saturn's atmosphere, so they'll be carried around by the winds, and this will help us to actually trace out where the vortices and the jets are actually occurring.
Reed wants to see if currents and vortices develop in the same way they do on Saturn's surface. The tank spins to mimic the rotation of the planet. the tiny particles start to spread out and interact. Slowly, the particles begin to swirl and create vortices.
Okay, so we can see evidence of a jet structure, and then here we can see a very nice rotating structure, which is basically an anticyclonic vortex.
Compare these to Saturn's twisting patterns of clouds. The similarities are striking. Reed's experiment suggests that a heat source within Saturn could fuel the raging storms. But what lies in its center that could generate that much heat? The gas giant is approximately 75% hydrogen and 25% helium, with traces of water, methane, and ammonia. Scientists believe that, like Earth, Saturn has a hot core. Earth's internal energy comes from radioactive materials in the core and residual heat from its formation. But here on Saturn, scientists think heat is generated by highly pressurized gases. Deep down in Saturn's atmosphere, the pressure of the gas builds. Near the core, the pressure is several million times higher than on Earth's surface. It's so powerful that the hydrogen and helium gradually turn from gases into strange metallic liquids.
If you get deep enough, then the hydrogen and helium become so dense that they don't behave like a gas anymore. They behave more like an electrically conducting metal.
This liquid swirls around a rocky core that is roughly the size of Earth. But just as oil and water can't mix, the liquefied metallic elements can't hold together. The heavier helium separates and sinks through the hydrogen. Scientists believe this movement creates friction that generates heat. Cassini is looking for evidence supporting this theory by measuring the precise abundance of helium in the atmosphere. It's already amassed a vast amount of data. There's so much that it will take years to analyze. Scientists hope to find out for certain how Saturn can give out 3 times more heat into space than it receives from the Sun. Cassini is unveiling Saturn's turbulent activity in unprecedented detail. Now its main engines fire, and mission control steer the spacecraft outward to explore one of the greatest mysteries in the solar system: Saturn's chaotic rings. Saturn has the largest and most spectacular rings in the solar system. The Voyager missions first revealed their awesome scale more than 25 years ago. The Voyager spacecraft show that the rings are chaotic. They're made up of billions of chunks of ice and rock colliding into each other.
If you were to fly over the top of the rings very close, so you could actually see them, you'd see something that would look a little bit like a flying boulder field. Small particles ranging between a fraction of an inch in size and maybe a couple of yards across.
The turbulent rings got scientists thinking. The particles orbiting Saturn resemble the disk of gas and dust that encircled our young sun 4.5 billion years ago. The particles started clumping together, growing larger and larger until after millions of years, they eventually formed the planets in our solar system. Could the same process be occurring inside Saturn's rings? Is this a good analogy for how planets may grow? Cassini sends back these stunning, highly detailed images.
I was very excited to see these beautiful, beautiful images. We're going to learn a huge amount just from the first couple of images.
Cassini uses an ultraviolet imaging spectrograph to map out the ring's structure with remarkable clarity.
The spectacular detail that we saw was just an eye-opener, and we stood amazed to see the structure that was in the rings, much more than I had personally expected.
As the particles pass in front of distant stars, the UV spectrograph measures the amount of starlight shining through. Areas that contain a lot of particles block starlight and appear darker. Where there are fewer particles, more light passes through. Scientists interpret the darker regions as temporary clumps of ring particles. They are known as moonlets. Cassini captures them on film for the first time. They appear as bright lumps within the rings.
These big boulders may very well be nothing but an agglomeration of the smaller ones. And these agglomerations may come and go with time as they bump into each other. They may just fall apart and collapse, and then they may reform by their own gravity and stickiness on the surfaces.
Scientists are fascinated by the images. They think this process happened in the early solar system. 4.5 billion years ago, the planets grew from microscopic specks to the size they are today.
The interaction between the moonlets and the ring particles is exactly like the interactions between a planet and the dust that's collecting to make that planet grow.
Cassini's spectacular images offer new insight into the processes behind the formation of our own world and the entire solar system. But where did all the material that makes up the rings come from? In its infancy, the solar system was a violent place. Comets and asteroids regularly collided with young planets, creating massive explosions and leaving behind scars that we can still see today. This image, modeled from real data, shows Saturn's tiny moon, Mimas. This giant crater dents its surface, a scar from a gigantic impact. Mimas was lucky. It survived the impact. But scientists think that Saturn could have lost one of its other moons completely, shattered into billions of fragments.
Imagine an object coming in that's the mass of a small planet or a big comet coming in. There's a huge amount of energy there. It could actually rubbleize it pretty well.
Saturn's powerful gravity could have captured the fragments and over time compressed them into a flat plane around its equator. These strange rings may be the result of the solar system's most intense period of planetary bombardment. They may also unlock the secrets of the solar system's birth 4.5 billion years ago. Cassini's next stop provides scientists with another opportunity to step back in time, to a world like Earth before life evolved. This is the mysterious moon, Titan. Cassini has crossed over 2 billion miles of space to reach Saturn and its moons. It carries with it a secondary space probe called Huygens, designed to land on Titan, one of Saturn's 60 moons. Titan is massive. It weighs almost twice as much as Earth's moon. It's an object that's perplexed scientists for decades. In 1980, Voyager 1 sends back these intriguing images of a world shrouded in a thick orange atmosphere. Analysis reveals that this is mostly made up of nitrogen, just like Earth's. The spacecraft also detects water and traces of organic compounds like ethane and carbon dioxide. Compounds that could provide the raw materials for life. Titan's atmosphere appears to be remarkably similar to that of early Earth. Now Huygens returns to pick up where Voyager left off, to search for signs of life. Dr. Carolyn Porco was a young PhD student on the Voyager missions.
You can imagine that for those of us who had been involved with the Voyager mission 24 years earlier, that there was a tremendous amount of anticipation in returning to the Saturn system.
Cassini's sophisticated cameras alone can't fully penetrate Titan's thick atmosphere. What's on the surface beneath the thick haze?
Our first pictures of Titan were very mystifying. In fact, our images are painted on this globe, and it's very difficult, if you look in details, to see exactly what you're looking at.
Cassini's probe, Huygens, is designed to solve this mystery. The probe hits Titan's dense atmosphere at over 13,000 miles per hour. At first, its cameras only transmit these images of a thick yellow haze. But at around 30 miles up, Titan's surface comes into focus.
It's just very difficult to describe accurately what it was like to see the first images that they showed of the surface of Titan, because they were mind blowers.
These images show an extraordinary desert-like landscape with low hills and rolling plains. But mission engineer Dr. Ralph Lorenz worries where Huygens will touch down.
We had no idea what it was going to land on. We didn't even know if it would survive landing. It could have landed in a lake of liquid hydrocarbons. It could have landed on a solid sheet of ice or a sand dune.
To the relief of all, Huygens lands on level ground and survives. It's the first probe to touch down on another world in the outer solar system. Onboard cameras reveal an eerie alien landscape. Lorenz rigged the probe with an instrument to analyze the composition of Titan's surface.
One thing it did is it had an instrument called a penetrometer, which was rammed into the ground and told us how hard the surface was. The texture was like damp sand or even a soft clay, and there were indications that there might have been a pebble or a crust on top, and there was even the joke that the surface was made of creme brulee.
The penetrometer reveals Huygens has touched down on soft ground, but not just any ground. Its camera shows smooth, round rocks, similar to those found in a riverbed.
There were a lot of rounded pebbles around, and the way you get rounded pebbles is that they're tumbled in a stream. And so this area, which had river gullies, must have been rained on sometime in the past, and the rain washed down, tumbling these pebbles.
Huygens discovers signs of liquid on the moon's surface.
So right away, there was this unambiguous sign of a process that we knew how to interpret. So this was tremendously exciting. It said there had to be liquid something flowing on the surface of Titan.
But is the liquid water? Huygens' thermometer registers the surface temperature as 290 below zero. In this bitter climate, water would freeze as solid as rock. But if water didn't carve this riverbed, what did? As Huygens continues to probe from the ground, Cassini moves to the moon's uncharted North Pole. Its radar penetrates the smoggy atmosphere to reveal dark patches. These indicate something astounding. Lakes. Liquid may still flow on Titan's surface. But what liquid can withstand freezing temperatures? Cassini's visual and infrared mapping spectrometer picks up a dramatic cloud system. It's enormous, engulfing almost the entire North Pole. Scientists suspect these clouds could supply the liquid that appears to fill Titan's lakes. Cassini homes in on the clouds and finds they are made of methane. It seems that Titan's surface has been carved not by water, but by liquid methane.
We've counted up the volume of liquid in some of these lakes, and it's hundreds of times the amount of all the liquefied natural gas, all the oil on Earth.
The super cold temperatures on Titan allow methane to exist as a liquid. Any water on this moon is frozen solid. Surface conditions are not conducive to life. But Titan's atmosphere is another story. Scientists focus in on the tiny particles suspended in Titan's atmosphere, first discovered 25 years ago. They are a cocktail of organic molecules, the stuff of life. Molecules like these existed on Earth 4 billion years ago. If scientists can understand how they form on Titan, they can figure out how they developed into life on Earth. Cassini isolates the exact mix of molecules and transmits its findings back to mission control. Astrobiologist Dr. Chris McKay has been trying to recreate Titan's atmosphere in the lab, using the data from Voyager.
As soon as the Cassini results came in, we scrambled to change our experiments, to line them up with the new information. It was like working on a problem for a decade and then finally seeing a glimpse of the answer in the back of the book and realizing, aha, this is the way to go.
McKay now tries to use this formula to turn simple organic molecules like methane and nitrogen into the building blocks of life. In his lab, he simulates Titan's pressure, temperature, and nitrogen-rich environment.
Here is a tank of methane and nitrogen. This is the starting mixture for Titan's atmosphere. It flows through the apparatus into our reaction chamber. So now I'm going to turn on the energy source, and this flow of methane and nitrogen will experience the same kind of energy processes that are going on in Titan's upper atmosphere.
Then McKay uses electricity to simulate the sun's ultraviolet radiation.
We have Titan in a jar.
After a few hours, the simpler molecules turn into complex nitrogen-rich substances called tholins. These lab-made tholins are almost exact copies of those found on Titan. Understanding how they form gives us valuable insight into the origin of life on Earth.
One overall question in studying Titan and comparing it to the early Earth is the question of how unusual is the sort of chemistry that led to life on Earth? Is it very rare and it happened on Earth because of very unusual circumstances? Or is it commonplace organic chemistry that we can expect on any world that's like Earth or even like Titan? And if we find that there's a common theme, a common way in which this kind of process goes, maybe the steps that lead to life are commonplace, and therefore life is commonplace.
The Cassini mission to Titan reveals how life could emerge on other worlds. On the surface, Huygens' batteries die out. Its landing represents one of the great achievements in the history of space exploration. Huygens provided a spectacular view of Titan and returned over 750 images and over 3 hours of data. Cassini abandons Huygens on Titan and heads for another moon, which scientists believe could be its greatest conquest, Enceladus. Cassini continues exploring the Saturnian system. In its sights, the moon Enceladus. Covered in ice, Enceladus is one of the brightest objects in the solar system. Cassini's cameras capture these detailed images of this dazzling, frozen world. Its ancient, wrinkled surface is made up of fractured plains, craters, and folded mountains. But as it skims past, Cassini's magnetometer registers some kind of disturbance. This is the actual recording. The moon creates fluctuations in Saturn's immense magnetic field. But how? The magnetometer detects gas coming from the moon's surface. Experts suggest it must have some kind of partial atmosphere. Planetary scientist Professor Bob Brown thinks this is impossible.
They said, hey, you know, we're seeing evidence of a tenuous atmosphere around Enceladus. And many of us responded with skepticism because an object like this can't have an atmosphere.
Enceladus is just 300 miles across. It has too little gravity to hold on to an atmosphere for very long. But things are about to get stranger.
The magnetometer group told us the atmosphere around Enceladus seemed to be concentrated around the South Pole, which is even weirder. Atmospheres don't do that. They distribute themselves uniformly around an object.
The team is mystified. What could create a strange, localized atmosphere? Cassini moves closer. The spacecraft captures this stunning image. Giant geysers on the surface of the moon appear to throw out huge plumes of vapor. The unidentified gas blasts over 400 miles into space.
To see this image, okay, where we have a dozen to 2 dozen jets, narrow jets, just emerging from the South Pole, was, you know, it's one of those things that a person who lives the kind of life I lead lives for. Okay, it was just one of those discoveries that, you know, you're not going to make often in your lifetime.
Cassini's spectrograph analyzes the vapor of the jets. It contains water. This discovery is completely unexpected. Could liquid water exist on this frozen moon? Cassini is looking for liquid water on Enceladus. It zeroes in on an area of the moon covered with cracks.
But one of the things that was absolutely stunning about this is that when we got into these areas where these cracks are, they're clearly a lot warmer. It may very well be that the temperatures there are as high as 0 degrees C. It may very well be that they're high enough that liquid water is literally very, very close to the surface.
Cassini has found a hot spot, an area warm enough to support water in its liquid form.
That was just, mind-blowing. Like, what could be possibly producing this? It's one thing to find a body to be warm. It's another thing to find that it's only warm in one location.
Scientists are baffled. What generates these pockets of heat? Enceladus's orbit is elliptical. Its distance from Saturn varies over time. One theory is, as it passes close to Saturn, its crust flexes. Then as it moves away, it relaxes. Friction at the fault lines generates heat. Perhaps enough heat to melt ice within the faults.
Enceladus flexes its body, okay, and so that can produce friction enough to melt ice, to create liquid water.
The prospect of liquid water on one of Saturn's moons demands further investigation. The first step is to determine the exact composition of the plumes. Mission Control fly Cassini just 30 miles above the moon's wrinkled surface, passing through the geyser's outer edge. Its instruments measure the composition. The results are completely unexpected. The plumes contain water vapor, nitrogen, and even simple organic molecules.
It doesn't take much of a jump at that point to make the association that if you have water, you have heat, and you have organic chemicals, you have the conditions that might actually produce primitive life.
Scientists now believe that Enceladus has conditions that can sustain life. Living organisms could survive around the warm faults that sit at its southern pole. The latest theories suggest that the faults in the terrain here may stretch down to a subterranean sea. This would be a dark world devoid of sunlight, but life may still have emerged here. On Earth, primitive organisms thrive in similar hostile and extreme environments. Scientists speculate that the same could be true of Enceladus.
There's the possibility of having something akin to those hydrothermal vents that we see at the bottom of the ocean. And we know there are living organisms there. There's chemistry that goes on there that living organisms can utilize to live.
It's a tantalizing possibility. If there are living things on Enceladus, the implications would be profound.
What could be a more important scientific discovery than to find out life has evolved separately in some other place? That changes the whole picture for human beings.
If we could demonstrate that the origin of life, Genesis, had occurred twice independently, then as far as I'm concerned, the spell is broken. We could safely infer life had occurred an astronomical number of times throughout the cosmos in its 13.7 billion year history. So this is why it is such a pressing question for us.
Cassini shows us that life may be possible on alien worlds. On April 15, 2008, more than 10 years after launch, NASA announces that the mission will be extended for a further 2 years. Parts of its tour will be dedicated to the exploration of Enceladus and Titan. Perhaps it will make the biggest discovery of them all: life on another world.
Jupiter, vast, mysterious. The largest planet in the solar system. Made almost entirely of gas, this violent world of 400-mile-an-hour winds and storms twice the size of Earth may also be the blueprint for how planets are formed. And on one of Jupiter's 4 largest moons may lie the answer to the most important question of all. Beneath these vast ice sheets, mankind could finally discover if alien life exists. Cutting-edge space missions are unlocking the secrets of this enigmatic giant, Jupiter. In the last 50 years, space missions have revealed worlds we never could have imagined. From the mountains of Mars to the methane lakes of Saturn. Yet one planet captures our imagination more than any other. The greatest of them all, Jupiter. Most of what we know about Jupiter comes from one mission, Galileo, launched aboard the Space Shuttle Atlantis in 1989. Each new discovery it makes deepens our understanding of Jupiter and its moons. It may also uncover evidence of how the solar system itself was formed. "11 times bigger than the Earth, yet probably without a solid surface. Jupiter is a ball of gas and liquid 90,000 miles across, with lightning superbolts 1,000 times more powerful than the strongest strikes on Earth. And a ring system like Saturn's, but too faint for our telescopes to see. The Great Red Spot, a single vast storm with 250-mile-an-hour winds. So huge, it could swallow the Earth 3 times over. 63 moons orbit this giant. Galileo will study 4 of them: Io, Europa, Ganymede, and Callisto.
Each of which would be a beautiful target for a space mission in and of itself.
Scientists expect dead and lifeless worlds 500 million miles from the Sun. Io, Jupiter's closest moon, is slightly larger than Earth's own moon. But Io is far from lifeless. Huge plumes of sulfur dioxide reach hundreds of miles into space.
Very peculiar surface with reds and yellows. Someone nicknamed it the pizza moon.
Ganymede, the largest moon, is a world of scars and frozen slush. And Europa, most mysterious of all. Its icy surface may hide a liquid ocean below. Where there's water, there could be life. A new generation of probes are set to explore the mysteries of the Jovian system. Juno, Europa Explorer, and the underwater probe, Endurance. 3 missions, 1 goal, to at last reveal the secrets of these alien worlds. Before Galileo, previous missions could only look from afar. In the 1970s and early 80s, Pioneer and Voyager gave us tantalizing glimpses of Jupiter and its moons, but they raised more questions than they answered. How did Jupiter form? What powers its vast storms? And why are its moons so geologically active? Before these questions can be answered, the team have to overcome a simple problem. Galileo is unable to carry enough fuel to reach its destination. NASA engineers need another way to get to Jupiter.
And they came up with a brilliant solution. We wouldn't go to Jupiter at all. We'd start by going to Venus.
By flying close to Venus and then Earth, using a gravitational slingshot method, Galileo steals some energy from the planets to accelerate itself toward its final destination, Jupiter. When Galileo arrives after a journey of 6 years, a small subprobe will detach and plunge into the depths of Jupiter's atmosphere. It will have less than an hour to analyze its surroundings before being crushed by the extreme pressure. Everyone expects Galileo to beam back extraordinary information. As the spacecraft nears the end of its journey, it coincides with a massive comet on a collision course with Jupiter. Galileo is in an ideal position to watch. It could find clues to one of the most important questions about Jupiter's history. How was it made? Up until now, scientists believe that Jupiter is made from the leftovers from the birth of the Sun, a primordial planet frozen in time. If so, the Sun and Jupiter will have very similar chemical compositions. The comet's impact will stir up chemicals from below the surface, enabling the team to analyze them and see if the theory holds true. They are about to get more than they bargained for.
I just couldn't believe that we were going to get a chance to see one body in the solar system smash into another one.
We had an up-close and personal view of this unique event.
The comet's name is Shoemaker-Levy 9, or SL9. David Levy is part of the team that first discovers it.
This was going to be the first time that a comet collided with a planet, the first time in recorded history. And we had no idea what we were going to learn from it.
The day arrives. On mountaintops and in space, more telescopes are trained on the same part of the sky than ever before. Some scientists believe Jupiter's thick atmosphere will simply swallow the comet without a trace. Others hope the impact will dredge up matter from deep inside the planet, giving us vital clues to its composition.
We were talking about the largest, biggest planet in the solar system being hit by a tiny comet. Most scientists thought it would be a fizzle. Boy, were we lucky.
As the comet approaches, Jupiter's massive gravity tears it to pieces. Now, 20 separate fragments will strike the planet, some a mile or more across. Astronomers across the globe are about to witness something amazing.
Yeah, that's it.
One by one, the fragments hit. The largest releases as much energy as 300 million atomic bombs. A fireball shoots 2,000 miles above the top of Jupiter's clouds. Each fragment produces a separate impact cloud, visible as dark black bruises in Jupiter's southern hemisphere. They're the size of the Earth.
The first thing we saw with each impact was either the plume of dust and gas, as seen by either Galileo or the Hubble Space Telescope. The next thing we saw was the formation of the large jet black cloud all over Jupiter's southern hemisphere.
But the real surprise doesn't come from the clouds. It comes from the shock waves the impacts send through the upper atmosphere. There's only one explanation, and to astronomers, it's a revelation.
When Shoemaker-Levy 9 crashed into Jupiter, it's sort of like a rock going into a pool. It sent out waves, and the speed of the waves depends on the amount of water in the atmosphere. And the speed was faster than we thought, and so we inferred that there was more water than we had expected. You can sort of see it here. You can see the ripples spreading out. And it was the speed at which the circles grew that told us there was more water than we expected.
The discovery is a surprise. It means that the composition of Jupiter is different from the Sun. It threatens to overturn everything scientists think they know about Jupiter's formation. A new theory is needed. In 17 months, Galileo will arrive and analyze Jupiter's chemistry firsthand. Only then can the team solve the mystery. One year after the comet SL9 strikes Jupiter, Galileo is on its final approach. There's a lot at stake. Scientists now know Jupiter may have 10 times more water than previously thought. If so, they may need to find a whole new explanation for how this strange world formed. Galileo's first task will be to directly measure the chemistry of Jupiter's atmosphere, including the amount of water. Galileo will release a small probe into Jupiter's clouds. The probe will also measure the wind speeds and temperatures at different depths to try and explain why the weather is so violent, as well as answering the big question: is Jupiter a long-lost cousin of the Sun, or something else entirely? As the probe dives into Jupiter's atmosphere, scientists are convinced they'll find the layer of water vapor the comet revealed, giving vital clues to the planet's creation.
And I even announced a prediction at a scientific meeting, offering to bet anyone in the audience $10 that the probe would find more than a certain amount of water.
But instead of water, the probe drifts through thin, wispy gases. It has flown into a downdraft, a dry gap in the clouds. Where is the water they were expecting to find? Jupiter must have both dry areas and wet spots. It's not what they expect.
What they discovered was that Jupiter has some long-term weather patterns, spots that move around that they didn't really realize were there before.
The Galileo team holds their breath. The probe dives deeper, but still there is almost no evidence of water. Less than an hour of data is about to trigger a revolution in our understanding of how the solar system formed. The probe does detect a high proportion of heavier elements like argon, krypton, carbon, and nitrogen. It finds levels 2 to 3 times higher than found in the Sun. These elements only condense at extremely low temperatures, lower than the temperature found at Jupiter's present position.
We learned that the atmosphere of Jupiter has chemical constituents that came in with very cold material from the outer solar system.
For astronomers, the discovery is a bombshell. The presence of these elements means Jupiter must have formed in a different way than the Sun.
This little probe, in one felt swoop, showed us that all of our ideas of how planets were formed were wrong. We didn't understand how the planets were made, and we didn't understand the early solar system.
The small probe's discoveries shocked the scientific community. Could the giant planet have formed further out in the solar system, where it's colder, then migrated into its current position? Or did comets or asteroids bring the heavy elements and water to it? After 58 minutes, and before the answers become clear, the probe falls silent, burning up in Jupiter's inner atmosphere. The probe has given scientists some remarkable insights into Jupiter, its atmosphere, and how it formed. But the big question goes unanswered. In 2011, a new mission, Juno, will attempt to find the answer. It will fly closer to Jupiter and gather more information than ever before. When Galileo's small probe plunged through Jupiter's atmosphere, it hit a dry spot. Just how much water Jupiter holds is still a mystery. Juno will take a different approach. Using the latest microwave technology, a radiometer, it will scan for water around the entire planet. Scientists hope that finding the missing data will finally solve the mystery of how Jupiter was formed.
What we're really after with Juno is the ingredients. From the ingredients of Jupiter, we're going to figure out the recipe. And that's what's going to tell us how planets are made.
With the probe having completed its work, it's now time for Galileo, 130,000 miles above Jupiter, to turn its attention to another long-standing mystery: the planet's weather. How can storms 3 times the size of Earth get so big and last for over 300 years? Jupiter's weather is a maelstrom of swirling clouds, lightning storms, and massive hurricane-like vortices. For the Galileo team, it's a mystery. On Earth, weather like this is powered by the heat of the sun. But Jupiter is 500 million miles away, so there must be some other source of power. Its most famous feature is the Great Red Spot, a storm whose clouds tower 5 miles above the atmosphere and plunge deep into a chemical soup below.
The red spot is red because of the chemicals that are trapped there in the center of the red spot have been baked and cooked by ultraviolet light and have turned red.
Astronomers have watched the Great Red Spot for at least 300 years. On Earth, even the biggest storms only last about 2 weeks. So how does the biggest storm in the solar system, 3 times wider than the Earth, get enough energy to rage unchecked for centuries? Scientists believe smaller thunderstorms could hold the answer. In order to solve the mystery, they had planned to video the Great Red Spot and other smaller storms in action. Understanding the mechanics of these turbulent weather systems, the Galileo team hoped to reveal the source of their power. With the high-gain antenna out of action, this simple solution won't be possible. The team back at Mission Control need a new approach.
Instead of making long, continuous movies, we made 3-step movies. You watch the red spot, you come back a few hours later, you watch it again, and so it's just a 3-step movie instead of a continuous movie.
Galileo homes in on a turbulent area of small white spots caused by what they think is convection or rapidly rising air. If these are storms, they will need to find proof. They need to locate another of Jupiter's most extraordinary features. Lightning bolts, 1,000 times more powerful than on Earth. But these are only visible at night.
Jupiter is 11 times bigger than the Earth. It's really big. If you look at this globe, you can see a few intense white-colored spots, small, intense white-colored spots. And when we got around behind Jupiter and looked at the night side, it was those very white-colored spots that had the lightning in them, and no place else. So that identified where the thunderstorms were.
Having identified the thunderstorms, the next step is to find out whether these small white spots can grow into larger ones. Galileo is in the right position at the right time.
There were some white ovals that formed in the 1930s, 3 of them, and they had been around for 60 years when suddenly 2 of them merged.
Galileo watches as 2 of the ovals merge to form a larger, more powerful storm. 2 years later, the 3rd oval also merges, forming one large storm in a belt below the Great Red Spot.
And then it had slowly turned red, so that it resembled the Great Red Spot, but not quite as big.
Nicknamed the Red Spot Jr., observations of its birth may also help to solve the mystery of where these large storms get their energy. Jupiter's storms are cannibalistic. They swallow smaller storms. This is how something as large as the Great Red Spot came into being.
It's like a food chain where the big fish eat the little fish and the little fish eat smaller fish. And the primary harvesters of energy on Jupiter are the little thunderstorms.
This accounts for the source of all the energy, but it doesn't explain why these vast storms last so long. Conditions on Jupiter are so turbulent that the storms should blow themselves apart. On Earth, vortices such as tornadoes soon die out, but on Jupiter, vortices last for years. Jupiter is the fastest spinning planet in the solar system, turning 22 times faster than Earth. Ironically, scientist John Arno thinks this rapid spin explains the stability of Jupiter's storms.
In rapidly rotating systems, vortices can be long-lived. It's very surprising. Normally we would think they'd shred themselves. They never do. What we've learned from these missions is that it's very coherent, is that it's very stable.
When two different colored dyes are mixed in a rotating jar of water, the results are startling.
At first, what looks like it's going to be a mess quickly turns out not to be a mess. Instead, we generate two large-scale vortices that you'll see are going to be very long-lived and coherent. And this is the idea. In rotating fluid systems, when you try to mix them, instead of just destroying any dye signal or any signal in the fluid, you get large-scale structures, similar to a great red spot.
Galileo has revealed why some storms get so big and last so long. But scientists are still mystified by Jupiter's most distinguishable characteristic, its parallel red, white, and brown stripes. It was assumed that some colors are rising gases and others sinking. But Galileo finds this may not be true. Although its atmosphere is hundreds of miles deep, only the surface layer is visible. Here, high-velocity winds blow in opposite directions, causing these multicolored patterns to be dragged across the surface.
The colored bands are associated with vertical motion, and some of them are mapping out rising motion and some of them mapping out sinking motion. It may be that the rising motion happens at one level and the sinking motion happens at the same bands but at a different level.
They won't find out until the Juno mission in 2011 looks through the top layer of Jupiter's atmosphere to see just how the planet is spinning.
Is it all spinning as one solid body like the Earth does? And what we see on the surface is just a bunch of clouds, a surface meteorological layer? Or is it inside a little bit like an onion, where there's different layers, and each layer is spinning in a different direction and at a different speed? We don't actually know that answer.
Juno will orbit Jupiter 32 times, each lasting 11 days. The orbits will pass over Jupiter's north and south poles, shifting longitude with every flyby to scan a new section of the planet. For the first time, Juno will map Jupiter's entire atmosphere down to a depth of 350 miles. Jupiter's vast weather systems may finally yield their secrets. Scientists now realize that the planet's fast rotation maintains Jupiter's long-lived storms, but more importantly, it also drives Jupiter's most powerful force, its magnetic field.
And we can study that system and compare it with what goes on at Earth and learn a lot that will help us understand Earth as well.
The Earth's magnetic field is generated by the churning motion of molten iron around the core. Jupiter is made of gas, but at its core, the hydrogen is so compressed, it acts like liquid metal.
The magnetic field is created deep down in the planet where the pressures are so great that the hydrogen in Jupiter has become metallic. It actually behaves like a metal. And so it's moving around and currents are being created. And these manifest themselves out into the magnetic field that surrounds the planet.
The metallic hydrogen churning in Jupiter's core creates an incredibly powerful magnetic field around the planet. It stretches across the solar system to Saturn and beyond, holding in its grasp charged particles and gases.
It's enormous, 50 to 100 times Jupiter's size going across, and the tail is dragged out by the solar wind all the way back to Saturn's orbit.
Jupiter's magnetic field is the largest object in the solar system. If we could see it from Earth with the naked eye, it would appear larger than our moon. It's also strong enough to divert the constant stream of sulfur emitted from the huge volcanoes on Jupiter's closest moon, Io. This material also funnels down toward Jupiter's poles, creating a breathtaking light display. Like Earth, Jupiter has northern and southern lights, called auroras. For the first time, Juno will analyze the charged particles and magnetic fields that create these huge displays.
We're flying close, we'll dive underneath the radiation belts and out the other side. And we'll fly through the charged particles that bombard and light up the atmosphere with the northern aurora.
The team hopes the study of Jupiter will yield a better understanding of the dynamic processes that create Earth's own magnetic field. But the Jovian system has other secrets to offer. Its moons are not cold and inactive, but dynamic worlds that may hold the answer to the ultimate question: is there life beyond Earth? The Jovian system is immense. 63 moons orbit the planet, some large enough to be planets in their own right. They are also an enigma. Small planets and moons usually cool faster, so how can these moons be so hot and geologically active now? The answer may also contain a clue to the holy grail of science. Is there life on other worlds? The 4 largest moons are Ganymede, Callisto, Io, and Europa. Each one is profoundly different and holds incredible surprises.
Where every time Ganymede goes around once, Europa goes around twice, and Io goes around 4 times. It's not a coincidence. These moons have evolved into this wonderful cosmic dance.
Astronomers had expected Jupiter's moons to be cold, dead lumps of rock and ice. What Galileo finds are active dynamic worlds. First stop, the mysterious Ganymede, the largest moon in the solar system. If it orbited the Sun instead of Jupiter, astronomers would call it a planet. These NASA images show its mountains, valleys, craters, and frozen lava flows. Almost immediately, the team finds something extraordinary. Galileo's magnetometer is picking up unexpected readings.
I was flabbergasted. The evidence right there that there was a magnetic field caused me to say, I don't believe it.
Ganymede is the only moon in the solar system with its own magnetic field. But it's a puzzle. The moon should be frozen solid. If Ganymede's got a magnetic field, it must have a molten core.
People had thought that a body of the size of Ganymede would have cooled off so much in the 4 billion years that the solar system has been around that it would have been solid all the way through. So we had to change our view of the evolution of Ganymede.
The discovery of Ganymede's magnetic field only deepens the mystery of how planets form. Something must have happened in Ganymede's past, something catastrophic enough to have heated up this moon.
Galileo showed us that Ganymede is a fascinating world, one that's gone through a very complex history, a world in its own right.
But as well as detecting Ganymede's normal magnetic field, Galileo finds a second varying field.
That's telling us there's probably also a liquid water ocean within Ganymede.
Scientists suspect this ocean is buried deep beneath the moon's rocky crust. The team is eager to investigate, but Galileo's orbit means it must leave Ganymede and move on. More surprises await. Next, the outermost of Jupiter's 4 largest moons. Callisto has its own mysteries. It's cold and rocky. The oldest and most heavily cratered landscape in the solar system. Its surface is scarred with ancient meteorite impacts. Scientists are perplexed by craters with strange bright rims. It seems dark surface material has slipped away, exposing the lighter material below. Nothing like it has ever been seen on Earth.
So what's the material made of that's slumping down? What's the process that's causing it to slump off? And it certainly proved to be a much more interesting body upon close examination than we ever thought.
Although the surface is a chilly minus 279 degrees Fahrenheit, Galileo's data suggests that just like Ganymede, Callisto can't be frozen solid. It detects a very weak magnetic field, suggesting it too may have an ocean. But the data is confusing. Other instruments aboard Galileo suggest that 125 miles beneath its surface, Callisto consists of a mixture of rock, metal, and ice, right down to its core. It's another mystery. The standard theory of how moons and planets form says that they should heat up when the material they're made of first joins together. The heat should then separate the rock from the ice. Strangely, on Callisto, it hasn't.
That would mean it never got really hot in there. How do you make such a large moon and not have it heat up? We still don't really understand Callisto.
Like so much of the Jovian system, Callisto raises more questions than it answers. We don't know what's going on inside the moon. We don't even know what material covers its surface. The story of Jupiter's next moon is equally bizarre. Io is the same size as our moon and is the closest of Jupiter's 4 large moons. It is the most volcanically active body in the solar system, with over 400 volcanoes, up to 124 miles across.
If you could have a bird's eye view of Io, it would be really extraordinary. You would see these plumes that are hundreds of miles high, these enormous lava flows, and big lava lakes just boiling and bubbling away on this surface that is all really strange and has these colors of pepperoni pizza.
Volcanoes constantly reshape Io's surface. Galileo's pictures are totally different from the ones Voyager sent back some 20 years before. But how can a landscape change so dramatically in such a short space of time? Huge craters seem to come and go. The cause of their disappearance seems to be giant plumes of sulfur-rich gases shooting around 200 miles above the surface.
We concluded that it was the plumes that were depositing fine material on the surface and actually erasing these craters over long periods of time.
But as with Jupiter's other moons, there is a further mystery. This much volcanic activity requires an immense amount of heat. But where does it come from? Io, 500 million miles from the sun, should be too cold. But clearly it's not. Could the answer be gravity? Jupiter's gravitational field keeps Io in orbit, but as it goes around, it passes on the inside of Jupiter's other moons. Their gravity pulls Io in the opposite direction. That distorts Io's shape. It's the distortion that creates the heat.
As Jupiter's large moons orbit around the planet, they're pulled and pushed and squeezed as they go around in their orbits. And this creates heat, friction, and causes melting within Io of the rock to power its volcanoes.
It raises tides on Io, very much like the moon raises tides on the oceans on Earth. Only on Io, the whole surface goes up by over 300 feet. Can you imagine what it would be like on Earth, like here in Los Angeles, if the crust of the Earth was rising 300 feet?
It's an astonishing discovery. A world shaped by forces so violent, it's pulled apart like taffy. Yet amazing as it sounds, of all Jupiter's moons, Io may not be the strangest. The next moon on Galileo's path, Europa. Its surface is covered in strange geological shapes and parallel tracks that cut across the ice. It's an ice world with an extraordinary secret. Could it harbor the ingredients for life? Images of Jupiter's moon Europa from earlier missions reveal a pinkish-white world. But Galileo finds fewer meteor craters than expected. That means something is erasing the craters after they form. Because Europa's surface is ice, scientists believe water could be welling up from below. This moon is so intriguing the team wants a better look. But to do so means spending more time at Europa than planned.
The original schedule called for only 3 flybys of the moon Europa, but the evidence was so compelling that it compelled the mission to be extended in length and to go back several more times.
Galileo's first job is to image the moon in greater detail. The question is, how active is Europa's surface? Are the processes that erase impact craters fast or glacially slow? The team begins by assuming the process could take billions of years. That changes fast.
I'm listening to them discussing the age of Europa's surface dropping. Oh, well, maybe it's a couple billion years old. And then the next flyby, well, it might even be 100,000 years old. And then the next flyby, it may be currently active.
While measuring Europa's magnetic field, Galileo uncovers another mystery. As the moon orbits Jupiter, its magnetic field shifts. Europa must have a conductive layer which allows Jupiter's magnetic field to pass through it. There is only one thing that could cause this, and it's a big surprise for the Galileo team.
We were able to interpret these signatures as being produced by a global ocean beneath the surface of the ice.
Scientists believe Europa's ocean is vast. It covers the whole globe to a depth of 100 miles, making it the largest body of liquid water in the solar system. If so, the team must first address a fundamental problem. Europa's surface temperature can reach minus 200 degrees Fahrenheit. Why doesn't such a huge ocean so far from the sun freeze? Astronomers think the answer may be the same one that drives the volcanoes on Io. Jupiter's gravity stretches and compresses the moon, creating heat within. It's the heat that keeps the surface in constant motion. This could also explain some unusual features found on Europa.
Galileo images showed that ridges crisscross the surface of Europa. These are bizarre features that travel across the surface for up to 1,000 kilometers, and typically in pairs. That is, a ridge with a depression in the middle and another ridge. These are bizarre features like nothing we see on the Earth.
At first, these ridges are a puzzle, but researchers soon come up with a solution. Planetary scientist Bob Pappalardo reproduces the effect with ice blocks in the lab.
As Europa is flexed by Jupiter's gravity, its surface bends and cracks and makes fractures through the ice. Well, as it's squeezed and bent, the ice slides back and forth along these fractures. Now this can create heat as these blocks move by one another. And that heat can warm the ice on either side of the block, and that warm ice rises up to form these strange ridges that we see, these tracks that seem to go across the tundra of Europa.
Galileo reveals a world in constant motion, evidence of heat hidden below the ice. Flows of material on the surface are possible evidence of ice volcanoes or geysers. Brown-red stains stretch across the ice where it has cracked open, and salty material from the interior has welled up from below.
We see pits and spots and domes on the surface of Europa that might be related to the rise of blobs of warm ice that move up through the shell, sort of like a lava lamp.
Heat from the interior of the moon may even drive hydrothermal vents in the ocean. On Earth, hydrothermal vents on the seafloor are hotspots for life. Galileo's data also suggests there's carbon dioxide frozen on Europa's surface, possibly welling up from the ocean below. If so, the find is huge, because CO2 is vital for life. Does this mean there's life on Europa?
I'm in the camp that where there's water, there's a very good chance that there's life, and where there's materials for that life to use. And on Europa, we seem to have the materials and we have the water.
If we search and find life within the ocean of Europa, that'll be an enormous leap in understanding whether we're alone in the universe or whether life may be everywhere.
The search for life is an irresistible lure. Scientists are desperate to go back to Europa, and near the end of the next decade, they hope to launch a groundbreaking mission to orbit the moon. The Europa Explorer will take the first steps toward answering the biggest question of all. Is there life on other worlds? It will survey the ice on Europa's surface. As well as analyzing its structure, it will search for spots where we could one day break through to the ocean beneath.
We need to measure the gravity in detail. We need to do radar studies. We need to look at the surface composition. We need to understand the geology. We need to understand that tidal flexing that heats the interior and causes that thick layer of ice to flex with the tidal forces.
The Explorer's main tool is radar. It will give scientists a 3D map of Europa's crust. This will tell them just how thick the icy shell is.
How far beneath the surface the ocean is, if it's a global ocean, how deep it is, how thick the ocean layer is.
These are crucial questions. Once scientists know how thick the ice is, the next step is to work out how to get beneath it, and that will mean a completely new mission. A probe that will not only orbit Europa, but land and explore its subsurface ocean. Endurance is already at work in Antarctica. A robotic submarine. It's the first of a new breed of underwater probes that can also operate under the ice. The aim is to create a vehicle that needs no instructions from home. Endurance must make decisions all by itself.
Every vehicle we've sent to space so far has the ability to talk back to Earth, get commands from Earth, and have people in the loop. This will be a whole new ballgame, and it's something that we're going to be able to test in Antarctica.
Endurance is currently investigating a lake hidden under nearly 15 feet of ice in Antarctica. Perhaps one day, a vehicle like this will search for life on Europa. But first, it has to get through the ice.
That thick ice cover, it takes a lot of energy to melt ice. People don't usually appreciate that. But we will need some kind of nuclear system that will melt that ice, and it will take weeks, perhaps months, to get through that ice.
We might imagine a lander spacecraft that melts its way all the way down to the ocean and explores what's really down there.
The discovery of life on another world would be one of the greatest finds of all time.
We're not talking about fish or whales or the Loch Ness Monster. We're talking about microbes. Could there be tiny single-celled organisms within the ocean of Europa?
I mean, if you just find bacteria, it would be fascinating. But who knows? You know, maybe there's something more sophisticated, there's something swimming around. Who knows?
Even the simplest life forms would have profound implications.
If life exists in the ocean of Europa, that would tell us that life probably exists almost anywhere there's a water-rich environment. That would be an amazing discovery.
Jupiter and its moons have already transformed our understanding of our place in the solar system. Now, new missions to Europa may finally prove that life on Earth is not unique. And if there's life on two worlds, then why not on many? Jupiter and its moons may one day give us hope. We will find not just life, but intelligence out among the stars.
3.5 billion miles from Earth lies one of the most captivating objects in our solar system. It's a tiny, icy world with the strangest atmosphere ever studied. It may have giant geysers, underground oceans. There's even a small chance it has primitive life. It's changing the way we look at Earth and our solar system. This is the former planet known as Pluto. Pluto sits on the edge of our solar system, 3.5 billion miles from Earth. Remote but not forgotten, for generations of school children, Pluto is the 9th planet. But on August 24th, 2006, Pluto lost its planetary status. It was reclassified as a dwarf planet.
Pluto doesn't care what we call it. It doesn't care whether we call it it's going to be the same object whether we call it a planet or a dwarf planet or a minor planet.
Pluto has all of the characteristics of the other planets. In the same way that a Chihuahua is a dog, just smaller. Dwarf planets are planets. They're a smaller variety.
Pluto sits on an exciting new frontier of space exploration. A state-of-the-art spacecraft is heading towards it at around 1 million miles a day. Scientists hope that it will shed new light on the formation of the solar system and even the birth of our own planet.
Every time we take a spacecraft and go by a new body, it turns into an entire world that is filled with fascinating phenomena that we would have never understood before.
The fact that Pluto is so far away, it's so small, it's so dim, and may represent now a whole new swath of real estate worth of objects, tells us that Pluto has a lot in store for us to learn about it.
Our story starts with Pluto's discovery. By the early 20th century, 8 planets have been discovered. Many assume that Neptune is the outermost. But astronomer Percival Lowell is convinced there is another planet out there, a massive planet whose gravitational pull is disturbing Neptune's orbit. He calls it Planet X, but it proves elusive, and for good reason. The giant planet theory is wrong.
The original motivations for searching for Pluto were based on bad data, basically. They just didn't have enough information then and good enough data to really solve this problem.
By 1929, astronomers at Lowell's Observatory outside Flagstaff, Arizona, had been searching for Planet X for 14 fruitless years. 23-year-old amateur astronomer Clyde Tombaugh joins the team and is given the painstaking task of comparing vast numbers of star-like objects. Tombaugh captures the images onto large photographic plates using a 12-inch telescope, small by today's standard. He's looking for tiny points of light that have moved across the night sky. Stars remain fixed while planets move. Tombaugh continues the search for over a year. Then, examining the plates taken on the 23rd and the 29th of January 1930, a faint object catches his eye. Flicking between these two images, he sees that the object appears to have moved. He checks and rechecks, making sure it isn't a comet or a blemish on the plate. It seems the young astronomer has discovered the astronomical Holy Grail, Planet X.
He also was extremely lucky to be looking at the right part of the sky at the right time. And of course, he had very keen eyes and skillfully able to pick out that small object as it moved across the sky.
Even though the giant planet theory turned out to be wrong, Tombaugh still found a planet. The new discovery is headline news. The planet is named Pluto, after the Greek god of the underworld. Based on their original miscalculation, they believe Pluto is bigger than Earth. Pluto officially becomes the solar system's 9th planet. Today, over 70 years later, Pluto is still pushing Lowell's modern telescopes and leading astronomers like Mark Buey to the very limit of their abilities.
Even with modern day tools, it's a difficult job to find these objects, and you have to look at a lot of sky, a lot of data, use the computers, use all these tools, and we work down at the very limits of what our data and our telescopes can do.
For decades, even the most basic questions about Pluto remain shrouded in mystery. And the most basic of all, its size. The breakthrough comes in 1978 with the discovery of Pluto's largest moon, Charon. It was a stroke of luck, as no one thought Pluto had any bodies nearby. Astronomers were able to estimate Pluto's mass by looking at its gravitational influence on Charon.
Now we know what the mass of Pluto is, and all of a sudden it goes from this vague, poorly known place to now you know something about it and can start putting it in context.
The results are surprising. Pluto is not larger than Earth. In fact, it's smaller than our own moon. Side by side, Pluto and Charon only cover the width of the United States. But for astronomers, the biggest mystery was why Pluto appeared to be on its own. In 1951, Gerard Kuiper theorized that Pluto was a remnant of a once massive belt of objects circling the outer solar system. This region of space became known as the Kuiper Belt.
Kuiper predicted a huge empty space where we see the Kuiper Belt. He thought that Pluto was a massive body that would have swept out all the objects there. And in fact, that's not the case at all.
Back then, Kuiper didn't know that Pluto was too small to have had this dramatic gravitational effect on other bodies. Maybe there was a belt of icy objects out there, just too small for them to see with their limited telescopes.
By 1985, it did seem kind of odd to me, and to other people I think, that the outer solar system would be a very empty place, where essentially nothing was known except for Pluto.
Mauna Kea, Hawaii. In 1988, Professor David Jewett of the University of Hawaii's Institute for Astronomy begins a dedicated hunt for another object beyond Neptune. Despite harnessing the latest digital technology, the task of looking for a tiny asteroid-sized object at the far reaches of the solar system is a daunting one. A bit like finding a grain of rice on a mountainside, as Jewett demonstrates.
To give you an idea for the scale of the Kuiper Belt relative to the orbits of the planets, I've laid out the solar system using various kinds of fruit and vegetables. So we have a ball to represent the sun. Next to the sun, which is the center of the solar system, we have the rocky planets. So we have to go out to 5 astronomical units, 5 AUs, to find Jupiter, the biggest thing in the solar system except for the sun. Then we go out from Jupiter is Saturn, located at 10 AU. Out from Saturn is Uranus at 20 AU. Uranus is the first of the ice giant planets, and Uranus has a near twin. It's called Neptune. Neptune is over here at 30 AU. And then just beyond Neptune comes the famous Pluto, represented here by a tasty macadamia nut. And Pluto moves in and out from the sun, but it's roughly located at 39 AU. So we'll put that back where we find it. Kuiper Belt starts roughly at the orbit of Neptune and goes out to larger distances. So we can represent that by grains of rice from this bag, which I'll drop on the ground, These are Kuiper Belt objects falling in space, and here they go, but in fact they go very far out. They go out in this direction, and in fact it goes out so far that I can't throw it far enough. It goes out to the hill in the distance, far beyond me.
But in 1988, all this is speculation. It's just a theory. There's no hard evidence of other objects in the Kuiper Belt. Dave Jewett continues believing there have to be more Kuiper Belt objects out there, somewhere. For 4 years, he toils in the thin air of Mauna Kea's high-altitude observatories. He has no idea how big or bright any of the objects might be. Then in late November 1992, he and his colleague Jane Liu spot a faint moving dot in the sky.
It was a very, very definite object, far above the noise, far above the threshold of uncertainty. We're completely sure that we found the first really slow-moving thing in the solar system since Pluto.
And it's small, just 140 miles across. Its diameter is just 1/10 of Pluto's.
If we were able to find one body in 0.1% of the sky, which was the case, then we knew there must be something like 1,000 times more objects than we'd found.
Jewett's discovery has astounding implications. Now astronomers know there are potentially thousands of icy bodies, escapees from early planetary formation, orbiting out beyond Neptune. And Pluto is just one of many. Perhaps Pluto is not a planet after all. The discovery of thousands of objects in the Kuiper Belt opens up a whole new realm of planetary possibilities. Pluto no longer marks the edge of the solar system. There are hundreds of objects in the Kuiper Belt waiting to be identified, and astronomers are scrambling to find the great prize, an object bigger than Pluto. In 1998, Professor Mike Brown at the California Institute of Technology joins the hunt. At the Palomar Observatory in Southern California, Brown's team embark on an extensive search.
We had started this project of scanning the skies 7 years earlier, and with the idea that we wanted to see if there was something bigger than Pluto out there. We thought there just had to be.
Unlike Tombau's manual method, the team uses a computer-controlled telescope with digital cameras to take hundreds of images across the whole sky.
Clyde Tombau used photographic plates, and he would take 2 photographic plates and compare them and look for something that moves. We now use the digital cameras instead, and the computer does most of the work that Clyde Tombau did.
On October 21, 2003, the computer records a snapshot of space and gives it a code, 2003 UB313. But with such a backlog of images, 2 years pass before Brown has a chance to review it. Like Tombau, it's now down to his skill and judgment to spot one significant object among thousands.
And suddenly this big bright object appears on my screen, and my very first reaction, what did I do wrong? Something must be wrong here. This can't be right. And I checked everything, and realized, no, this is really there. And I immediately picked up my phone and called my wife and said, hey, I just found a planet.
2003 UB313 is around 70 miles wider than Pluto. And though it's 3 times further out than Pluto, it's one of the brightest bodies in the Kuiper Belt. Astronomers call it Eris.
We knew immediately, once you start discovering other objects beyond Neptune and look at the distribution of their sizes and the rate at which you're discovering, it was just a matter of time before you would find one larger than Pluto. And in fact, that's happened.
I never actually really thought we were going to find that one bigger than Pluto, so it was sort of a fun moment.
For Brown, Eris is the discovery of a lifetime. For Pluto, the implications are serious. No longer alone, and not even the biggest or brightest body beyond Neptune, can we still call Pluto a planet? One of the first to publicly question Pluto's status was director of New York's Hayden Planetarium, Dr. Neil deGrasse Tyson.
We first opened to the public in the year 2000, not including Pluto among the ranks of the other principal objects in the solar system. And, we got raked over the coals by the New York Times had a page one story saying, Pluto not a planet? Only in New York, okay? And then I got like hate mail from third graders, ever since.
Tyson leaves Pluto out from the display because it doesn't fit into his two main planetary categories: the inner rocky planets and the outer gas giants.
Pluto's always been a curious object, primarily because we've known so little about it.
Defining a planet is not as simple as it seems. Take Neptune's moon Triton, for example. Although it's 40% bigger than Pluto, Triton is just a moon. After much deliberation, the International Astronomical Union came up with a new definition. Planets now have to meet three basic criteria. They have to have sufficient mass for gravity to contract them into a sphere. They have to orbit the sun and not some other body, or else they would be moons. And lastly, they have to clear the material around their orbit. Unfortunately, Pluto fails to meet one of the criteria. It does not clear the neighborhood around its orbit. On August 24, 2006, Pluto is reclassified as a dwarf planet.
The word planet hasn't been defined since ancient Greece. Back then there were 7 planets: Mercury, Venus, Mars, Jupiter, Saturn, the Sun, and the Moon. And it was never redefined to accommodate our new understanding of the solar system.
Pluto may have lost its planetary status, but it hasn't lost its intrigue. The more scientists learn about Pluto, the stranger its story becomes. Unlike all the other planets, Pluto's surface is covered with exotic ices, such as frozen nitrogen and methane. There are at least 3 moons orbiting Pluto, a planet 2,000 times less massive than Earth. And Pluto's eccentric orbit is more like a comet's. For almost 60 years, it was also impossible to tell whether Pluto had an atmosphere. And when scientists finally get a chance to look, they discover something remarkable. Pluto's atmosphere is unique in the solar system. It's causing the planet to shrink. Pluto, once an isolated planet, the 9th in our solar system. Now stripped of its planetary status, Pluto is just one of thousands of icy bodies in the solar system's furthest reaches. It might not be alone, it might not be a planet anymore, but Pluto is still intriguing. And as scientists unlock the mysteries of Pluto, they're discovering a world full of puzzles and surprises. Astronomers figured out that Pluto was cold and that its surface was encased by ices, but for 58 years, they couldn't tell whether it had an atmosphere. No telescope on Earth was powerful enough to confirm this basic phenomenon on an object 3.5 billion miles away.
Even using the most powerful telescope available to astronomers, the Hubble Space Telescope, which is a fantastic instrument, Pluto just looks like a barely resolved, very pixelated object. We just can't see much detail.
On June 9th, 1988, NASA's Kuiper Airborne Observatory takes to the skies. Astronomers board this specially equipped high-altitude plane on a journey to the Earth's stratosphere. Their mission is to search for evidence of an atmosphere on Pluto by observing a strange celestial phenomenon. The only way to identify an atmosphere on a remote body like Pluto is to observe it during a type of eclipse known as an occultation. When a celestial object, like a moon or a small planet, passes in front of a star, starlight is sharply cut off if there is no atmosphere present. But if the body does have an atmosphere, the starlight behind it gradually dims as the body passes in front. On board the plane, high-powered telescopic instruments record the critical moment.
Hey, wow, okay. I think that thing has an atmosphere, guys. Yeah. Yep, atmosphere.
Pluto has an atmosphere. It's similar to Earth's, but extremely thin.
Pluto's atmosphere has many of the same chemical constituents as the Earth's atmosphere, but there's very little of it. If we took all of Pluto's atmosphere and we cooled it down even further than its current cold temperature, and it collapsed onto the surface as a frost or snow, we'd have snow up to the kneecaps.
But how does Pluto have an atmosphere under these frozen conditions? The answer turns out to be linked to its eccentric orbit. Most planets take a roughly circular route around the Sun, but Pluto follows an extreme elliptical path. Its orbit carries Pluto as close to 2.9 billion miles from the Sun and as far out as 4.6 billion miles. By contrast, Earth's distance from the Sun varies by just 3 million miles. Pluto receives almost 3 times more sunlight at its closest point to the Sun than at its furthest point. As it moves towards the Sun, Pluto's surface ices turn into gases. The result is a unique atmosphere. It comes and goes. Mark Buey of the Lowell Observatory in Flagstaff, Arizona, explains that Pluto's strange atmosphere is, in effect, turned off and on by the Sun.
This is a little bit like what the atmosphere of Pluto might be like when Pluto is closest to the Sun. And then as the Sun goes away from Pluto, this is what happens. We're going to stick this balloon into this really cold liquid, and the balloon starts to collapse and shrink and get smaller and smaller and smaller as the pressure of the gas inside goes away. And hold it here long enough, and now I have a totally collapsed balloon. Now you'll notice as I pull it back out, it's starting to warm up again. There's actually liquid air inside there. And the gas starts to expand and swell up. And this is kind of what happens with Pluto's atmosphere, we think, over the course of its year. At perihelion, or when it's closest to the Sun, you have this big atmosphere, and then when it gets furthest away from the Sun, the atmosphere shrinks and could maybe even disappear entirely.
No other known body has such a radically fluctuating atmosphere. And the more scientists study it, the stranger it becomes. Fran Bagenal, professor of astrophysical and planetary sciences at the University of Colorado, thinks that Pluto looks like a comet because it has an atmosphere that leaks into space. Pluto's gravity is so weak that its atmosphere stretches hundreds of miles above the surface.
Similarities with the comet are that the weak gravity of Pluto allow the atmospheric gases to escape. And so, as Pluto gets closer to the Sun, you have greater evaporation and more material escapes. Indeed, it looks very much like a comet in that respect.
When a comet travels towards the Sun's heat starts to affect its icy surface. Ices turn into gases and are blasted away, giving the comet its distinctive tail of ionized gas and dust. Although Pluto doesn't release dust like a comet, it does leak up to 0.5 ton of atmospheric gases every second. And this leads scientists to a startling conclusion. Pluto must be shrinking. Each time it heats up, it gets a little smaller. During our solar system's lifetime, as much as 18 miles of Pluto's terrain may have been lost to space.
And so as a result of this, we expect there to be a considerable variation in the surface, hills and valleys that have evolved over the age of the planet.
Hidden for decades, Pluto's strange surface is obscured to even the most powerful telescopes. But there is a special type of device that can bring it into focus. The infrared spectrometer reads the distinctive reflective signature of Pluto's surface. Using this technology, scientists can piece together a remarkable picture of the strange world of Pluto. Spectrometers tell us that Pluto's surface is covered by exotic ices. Temperatures on Pluto drop to a chilling -396 degrees Fahrenheit, so that nitrogen, methane, and carbon monoxide exist as frozen solids. The gases we breathe, see through, and move through on Earth make up Pluto's rocks, plains, and hills. Astronomers think that around 30% of Pluto is made up of ices. Beneath the exotic ice-covered surface sits a water-ice mantle. But is Pluto just a frozen world? As scientists investigate this puzzling dwarf planet, an intriguing possibility emerges. Could there be an ocean hidden beneath its surface? Could the existence of ice and liquid water on Pluto provide further evidence that the Kuiper Belt was a source of Earth's water? Scientists believe that Pluto-like worlds may have played a fundamental role in bringing water, the vital ingredient for life, to Earth. In the outer solar system where the sun's influence is weak, water ice is abundant. But could Pluto also have liquid water? Professor Bill McKinnon of the Washington University in St. Louis thinks so. He believes that beneath Pluto's frozen surface, there could be an ocean. McKinnon believes that water on Pluto could exist in liquid form due to the presence of ammonia, which acts like antifreeze. If he's right, water could remain liquid at temperatures far lower than those of the Antarctic.
Bodies like Pluto can actually have oceans. Not oceans on the surface like on the Earth, but oceans down below. And I have basically Pluto right here in this glass, and I can add the water and something like ammonia that would be inside Pluto.
Add ammonia to water, and the freezing point plummets to nearly -142 degrees Fahrenheit.
And to make it look more oceany, although we have no idea what the color of Pluto's ocean would be, we'll add some food coloring. Now out there in space, you're a long way from the sun, so it's cold. And so the top will freeze, like on a lake or in the Arctic, and you'll actually start freezing from the top down, and you'll make a thicker and thicker layer of ice, and I'll start it off by adding some ice at the top, which will float. And then, because we can't actually go into deep space, we'll put it in the freezer. But I put an earlier version of this a couple of hours ago, and this is sort of what you'd actually get. You'd actually see an icy layer floating on, I can jiggle it a little bit, a liquid layer that actually won't freeze.
After 2 hours in the freezer, the ammonia keeps the water liquid. But turn the temperature down below -142 degrees, and even ammonia-rich water freezes. On Pluto, surface temperatures are a mind-numbing -390 degrees Fahrenheit. At temperatures this low, every drop of water should freeze. So for water to remain liquid under the surface, there must be another force at play. a force that scientists believe lies deep inside Pluto's inner rocky core. Here there may be radioactive substances which generate heat as they decay. This heat could raise Pluto's subsurface temperatures to the critical level where ammonia-rich water can exist. It's a tantalizing theory, because whether in liquid or frozen form, the presence of water on Pluto and its Kuiper Belt neighbors could hold the key to one of our planet's greatest mysteries: the origin of its oceans. One popular theory suggests that comets, which are rich in water ice, may have delivered water to Earth. But Dave Jewett thinks comets may not be the only source of Earth's oceans. Jewett believes Pluto-like bodies in the Kuiper Belt may also have played a part. It would take roughly 1 billion average-sized comets to deliver Earth's water, or one single ice ball 600 miles across. No comet this large has ever been discovered. But in the Kuiper Belt, there are between 50 to 100,000 ice-rich objects larger than 60 miles in diameter, and dozens at least 600 miles across. At the dawn of the solar system, astronomers estimate that the Kuiper Belt was around 100 times more massive than it is today. Sometime in the past 4 billion years, the Kuiper Belt has shrunk.
Several tens of Earth masses, even up to 100 Earth masses of stuff, originally was present in the Kuiper Belt and then was lost by some process that remains mysterious.
Could this loss coincide with the creation of oceans on Earth? This is Neptune, the 8th planet and the Kuiper Belt's closest gas giant. Computer simulations show Neptune's huge gravitational field may have dislodged Kuiper Belt objects, sending them spiraling toward the Sun. Parts of them may have collided with Earth.
We know there was a period of time when there was just stuff slamming in all over the place. And that had to hit the Earth too. It's possible, entirely possible, that those objects were Kuiper Belt objects, which are full of ice and water. Most of the water is hanging out in the outer solar system, and all the rocks are in the inner solar system, but maybe by these stirring events, you can kind of bring these two areas together.
If the theory is correct, objects like Pluto in the Kuiper Belt played a part in delivering Earth's water, vital to all life as we know it. Pluto is slowly yielding its secrets, shedding new light on our solar system. But incredibly, almost 80 years after its discovery, we still don't really know what Pluto looks like. Despite powerful modern telescopes, there are no detailed images of Pluto. These, taken in 1994, are the clearest to date. They were captured by Hubble, the space telescope that escapes the distorting interference of Earth's atmosphere. The largest point of light in the center is Pluto. Its largest moon, Charon, is next to it. To construct a global map of Pluto's surface, Mark Buey turns to Hubble's infrared images.
Each one of these images represents one picture taken with the Hubble Space Telescope. You stitch all those pictures together into a uniform map, which then I can manipulate and make it look like a globe.
This composite globe shows a reddish surface with patches of light and dark, evidence that Pluto has a varied landscape. At the solar system's outer limits, beyond the reach of even the most powerful telescope, Pluto remains shrouded in mystery, but not for much longer.
You either need a bigger telescope or you gotta go there. And so, we're going there.
Right now, a sophisticated spacecraft is racing towards Pluto at around 1 million miles a day. It's ETA 2015. January 19th, 2006. The Atlas V rocket blasts off from Cape Canaveral, Florida. On board, the New Horizons spacecraft. It's on a 9-year journey to Pluto and the Kuiper Belt. This is a voyage into the unknown. Since NASA's inception in 1958, its missions have provided stunning pictures and vital scientific information about our solar system. Some have even involved robotic landing vehicles to examine and explore these new worlds up close. NASA has sent spacecraft to every major body in the solar system, except Pluto. Pluto is still waiting to be explored. In the first ever image of Pluto taken almost 80 years ago, the planet appears as a tiny pinprick of light, no brighter than a distant star. Even the latest images, captured by the Hubble Space Telescope, show Pluto as just a blurred ball of light.
Pluto is so far away and so small that Hubble's capacity to see detail is greatly limited.
To get a sense of what it's like to try and see Pluto, the best thing to do is to think about if you were to look at a ping pong ball, someone was to carry it 25 miles away.
An important clue to Pluto's appearance comes from data gathered by another mission to the outer solar system. In 1989, NASA's Voyager 2 skimmed past one of Neptune's 13 moons, the mysterious Triton. This flyby provided astronomers with a tantalizing glimpse of what Pluto might look like.
This icy moon, this large icy moon, that's very much a companion to Pluto, similar size, similar part of the solar system, and maybe had a very similar origin.
Astronomers theorize that many billions of years ago, Neptune slung Pluto outwards and dragged Triton towards it, taking it captive as a moon.
Triton is just like Pluto, but it got captured by Neptune billions of years ago. If we were to fly over Pluto, we would see impact craters and volcanic calderas or collapsed craters, and maybe even active venting or plumes, because we see these things on Triton.
Triton's strange landscape suggests that Pluto could be a dramatic place. And on Triton, the most dramatic features of all are geysers. Voyager 2 captured these remarkable images, evidence of geysers that last for up to a year and spurt gas and dust up to 5 miles high. If there are similar geysers on Pluto, astronomers predict that they would be driven by the sun. Although the sun is over 3.5 billion miles away, its heat may still have the power to affect the ice beneath Pluto's surface, turning it into gas. Pockets of subsurface gas would build up and eventually burst through Pluto's frozen surface as geysers. Will Grundy demonstrates how even a small increase in temperature produces a large geyser.
Okay, we're going to put liquid nitrogen into this plastic bottle, and it's very cold at 77 degrees above absolute zero. So as soon as it comes into contact with the hot environment here with the sun shining and the warm air, it starts boiling like crazy. And as it boils, it's going up into gas, giving off a huge amount of gas. And as soon as I screw the lid on, the gas has nowhere to go except up the tube in the lid and out through this cooler full of ice to form our simulated geyser. And here it comes. On the surface of Pluto, don't know what the scale of those geysers would be, whether they'd be very small like this one or maybe a kilometer tall.
Such mysteries will be solved on New Horizons' arrival in 2015. The spacecraft's camera has already been tested 6 months into its epic journey, capturing perhaps the greatest volcanic eruption ever witnessed in space. 76 years after Pluto's discovery, and after 17 years of research and development, NASA's New Horizons spacecraft sets out for Pluto. Traveling at around 1 million miles a day, it's on a 9-year, $700 million journey to reach Pluto and reveal its secrets. New Horizons chief scientist is Hal Weaver.
Yeah, where we are right now is mission control for the New Horizons mission to Pluto. This is where we watch all the activities that are occurring on the New Horizons mission. We have over here to the left a depiction, a software prediction of exactly where the spacecraft is, where it's pointed. You know, we're following it on its path to Pluto.
In early 2007, New Horizons passes Jupiter, using the planet's intense gravity to boost it toward Pluto. It took the opportunity to test its camera on Jupiter's largest satellite, Io. The results were spectacular. This footage, captured by New Horizons' long-range reconnaissance imager, shows the actual eruption of a volcano on Io's surface.
We were just lucky and happened to catch it when one of the major volcanoes was active. It had spectacular plumes, debris, volcanic debris was flying up for a couple of 100 miles above the surface.
It's a stunning but short-lived encounter. New Horizons soon leaves Jupiter behind. Traveling at over 8.5 miles a second, it's the fastest spacecraft ever launched. It's going so fast that after its 9-year journey, New Horizons will only have a day and a half to see Pluto close up before disappearing deeper into the Kuiper Belt.
And that's great for getting there early. But on the other hand, of course, that means that everything is really sped up as we fly by, because unfortunately, we can't just go to Pluto, put on the brakes and stop and hang around for a while. Roughly 3 months out, we're going to have resolution that's better than Hubble, and then it just gets better and better and better as we get closer and closer. But for those last 24 hours where we have this really high spatial resolution where we can see football field-sized features on the surface of Pluto, that all happens very quickly. We're just going to fly by and then just by Pluto and on deeper into the Kuiper Belt.
With such a short window to capture data, the team must test and retest the instruments throughout New Horizons' 9-year journey.
Every year, for about 2 months, we're going to wake the spacecraft up and do some testing. Some observations of celestial objects and some commissioning testing of all the instruments to check them out, to make sure they're still performing, and they'll be ready to go when we finally get to Pluto in July of 2015.
Ready to answer some of science's most fundamental questions.
The delivery of organic material and water from the outer solar system to the inner solar system may have played a pivotal role in the formation of life on the Earth.
It's just one of many questions about the solar system and its formation that scientists hope New Horizons will help answer. But above all, when New Horizons arrives, astronomers are expecting the unexpected.
I think the most exciting things that we're going to learn from New Horizons are all those things that it never even occurred to us to ask. And suddenly you go there and you realize, wow, we didn't know anything.
One thing is certain. The arrival of New Horizons will be the astronomical event of the 21st century.
It's a whole new kind of world. It's a planet I think everyone has tried to imagine. It's a frontier world. It's going to be the cover of the Rolling Stone.
And perhaps most fittingly, the spacecraft carries the ashes of the man who started the journey to Pluto almost 80 years ago, Clyde Tombaugh. This is a journey to one of the solar system's most puzzling, most mystifying worlds. Once the 9th planet, now a dwarf planet, an isolated oddity that became one of many. A frozen wasteland that could be home to giant geysers and underground oceans, and even possibly to primitive life. With so many twists to Pluto's story, who knows what surprises lie waiting to be discovered? Waiting for New Horizons' arrival in July 2015.